Agenda's up on the screen. Over to you, Chair.
Okay, well, welcome everyone to SRB 26. 25 or 26?
25.
26. Oh.
No, you're just counting one extra.
Thinking ahead.
Okay. We have adoption of the agenda.
Two. I can't. Sorry, Dara, I can't seem to zoom in. Oh, there it is. I got it. There we go. Okay.
Okay, we have adoption of the agenda, and let's get started on IPHC process with Dave.
Fantastic. Thank you very much, Chair. And so just a reminder that we will drop into. Oh, yeah, we're just going to hold for one more minute. Sorry. Back over to you, Chair.
Resume, please.
Okay, so we've adopted the agenda, and in terms of IPHC process, just a reminder that with the report, we will drop in the mandate of the SRB as paragraph 2. It's just standard so that anybody else who's picking up the report understands the overall mandate and where to look for the board's terms of reference in the rules of procedure. So agenda item 3.1 is the SRB annual workflow. And so this is just a verbal reminder that this is the second SRB meeting for the calendar year, feeds directly into the Commission's decision-making process. So we have the work meeting, the informal work meeting, which was held a couple of weeks ago. And they sort of hear about your previous recommendations and requests for action by the Secretariat and others. And then anything coming from this meeting will go directly to the interim meeting and then to the annual meeting. And hopefully the chair, or if not, one of the other board members will be able to present those recommendations directly to the Commission. So that's just a reminder. Yes, go ahead.
Did I hear we're going to present something to the interim?
So ideally, well, not ideally, the report of the SRB goes to the interim meeting, and it's an online meeting only. And so if you're available to briefly present the core outcomes or core recommendations from the SRB, that would be ideal. It's not essential.
When is it? It's probably on the meeting schedule, but I have it right now because
I don't want to misquote. So the interim meeting is the 5th and 26th of November. So it'll be the full day on the 25th and then a half day, usually less on the 26th. So if you're available for that, we can work through that in terms of logistics. Alternatively, they already have been presented with the initial recommendations from the previous SRB, and so we can just update them. Presentation at the AM 101 in Vancouver next year. Should be an easy one. Okay, moving on. In terms of the update on the actions arising, if we could just have that paper up, please, 03. So this is just the standard working paper that we provide to you at each SRB meeting. And so this is the update from the actions arising from the previous SRB meeting. All of these are provided as updates throughout the course of the next couple of days by various presenters. And so I don't intend on stepping through them, just our usual sort of process. But I will flag the recommendations associated with recommendation 02. Which was a direct recommendation for a separate meeting between the SRB and commissions to clarify the intended use of the MSE and possible processes for adopting a formal management procedure. And so just as a sort of an informal update at this point, and I'll be asking both of the science advisors online to provide direct input in just a moment when we get those observer updates. At this point, the Commission met informally at the work meeting a couple of weeks ago in Bellingham. reviewed that request and has provided a series of other clarifying comments and positions from the commission. And so Alan's going to pull those up and talk about them a little bit as well. And hopefully that will help us a little bit in moving that forward and making a plan to meet with commissioners or not, depending on the recommendation. But just hold tight on that one, and I am going to ask, because we did agree at the work meeting that the science advisors would provide some direct feedback from their commissioners to you under those observer updates. So keep you in suspense there. Hold tight. The rest are just the standard recommendations, requests, and updates, and what the status is, where it's presented in a particular paper as an update. We make reference to that. Any questions? Comments? Not seeing any. Let's move on. So we could have the next, well, actually, don't worry about bringing the next paper up. Paper 04 is the outcomes of the 100th session of the IPHC annual meeting. And so this is essentially the same paper with a few additions associated with some of the intersessional actions of the commission. It's just an updated paper. It's just there for reference. And if you have any questions throughout the course of the meeting, we can come back to it, bring it up, and discuss any of those actions. Any questions? If you recall back to the SRB024 meeting, if you could just bring up the agenda again, please. If you cast your mind back to the previous SRB meeting, we also had a discussion around a statement on climate change. And the SRB requested that a particular paragraph referencing that document, the statement on climate change, be incorporated into the SRB report. And so I would just propose that we do the same, noting that this is something that's sort of going to be ongoing. And the commission would like the SRB to take anything related to climate change into discussions and the recommendations that you make. And so if you, just as a quick reminder, it's a link to the specific policy paper on the website, and the SRB agreed to consider and advise on the potential implications of climate change for the conservation and management of Pacific halibut and any related impacts on contracting parties. So just as a standing process item. Objection to including that paragraph again?
No objection. I wonder if maybe we could elevate that in the discussion at some point. That wouldn't have to be this meeting, but something where we can review the evidence for climate change impacts and how they're being incorporated into the process. You know, having a statement is great, but spending some time focusing on it.
Yeah, through the chair, I agree. And one of the other recommendations from the SRB, I think it was the previous meeting, SRB023, was to update the 5-year program, integrated research and monitoring, with the activities that have already been completed, and then trying to at least articulate or highlight where some of those climate impacts will be incorporated into our work. And so I think that might also be a great avenue for trying to encourage discussions as we move forward. There's no other questions. We can move on to the observer updates. So Anne-Marie, if you're online, we can pass you the mic, and over to you. Can you hear us, Anne-Marie?
Yes. Sorry, just needed a little bit to get the microphone on.
Over to you.
All right. Good morning, everybody. Let's see. From the Canadian commissioners, I was talking to them after the work meeting. 2 main things that popped up. One is the FIS, and the other one is about the MSC harvest strategy policy. Agenda item on the FIS. Probably not a surprise that the costs continue to be a concern, and expectation is that it's going to be continue to be a concern for the next few years. And so one of the questions that came up was, what would a like minimum or a good enough FIS design look like that we could implement for another 3 to 5 years until longer term plan for more stable funding could be put in place to implement that more desirable block design, rotational block design, for example. I guess there's two parts to this. One is like minimum from an economic, and then one from the scientific perspective. But question for the SRB is obviously a focus more on the what is the minimum scientific design that we could limp by with for another few years. An additional question for the SRB is, I think, a question that's come up before, but in terms of like what's an acceptable range to be in for CV as well as for a bias, with the acknowledgement that in the past when this has come up, particularly around the CV, is that it comes back to the question of, well, it sort of depends on what the commissioners need in terms of the allocation to regulatory areas. And so maybe the two options for this one is, are there some questions that the SRB can help advisors, help staff come up with to elicit this, what do the commissioners need? Like what sort of things should we be asking the commissioners, or what sort of things should we be putting in front of them to be getting feedback for or on? Or a secondary thought was there had been some discussion around having a direct meeting between the SRB and the commissioners so that staff and advisors aren't playing telephone between the two groups. And maybe that might be a topic that could come up in that type of meeting. So those are my FIS questions or FIS items. The MSE Harvest Strategy Policy is
Marie, can I interrupt you?
Please.
Okay. Let's just pause because I'm not sure I fully understood the FIS one.
Okay.
I got most of the first part, but I was in the middle of writing a follow-up question when you started the second one, which was you're looking to see if there are questions that could be put to the commissioners.
Yes.
To help them choose what?
It's more of, I think the underlying question that I got from them is, what's an acceptable range of CVs? Like, I think right now we're at, somebody's going to have to kick it. It's like 15%. And we've been talking about, potentially increasing that. And so they're like, well, increase to what? What is, what is an acceptable range in terms of a maximum CV? And then also a question in terms of bias, because Ray had presented on bias well at the work meeting. And I know that we've gotten that question before in terms of, what is an acceptable CV to have? And I think I remember Olaf saying that, the halibut CVs, like we could only dream of that in some of our other fisheries. But staff have mentioned in the past that the reason why our coast-wide CVs are so low is because we need regulatory area CVs in a certain range so that the commissioners can make decisions around distribution of the coast-wide allocation to the regulatory areas. And so it becomes a little bit of a circular sort of question in terms of, well, what's an acceptable range from the commissioners? It's like, well, it depends. We're using the regulatory area CV so that you can distribute allocation. And then so it feels like there needs to be something that sort of takes us out of that do loop of the same two questions back and forth, and sort of hoping that you might have some thoughts as to ways to elicit the uses that the commissioners have for the regulatory area, like the information that they're getting at the regulatory areas, whether something else might be, like whether there's a different proxy that might be used or something else.
Okay. I think we're going to see some really interesting results today about the first part of that question. The issue of minimum CVs has been going on as long as I've been here. we're finally getting, because this came up in June. So we asked for some work to be done. So I think we're going to see some good, some interesting results on that may start to bring this question, some resolution to these questions. At least more information than us saying 8% is unbelievable and 30% is good enough. That's really. So anyway, maybe we can follow up later.
Sounds good.
Towards the end of the meeting to see if you've got some new information to work with.
Okay.
And then you talked about meeting, the proposed meeting with the SRB.
Mm-hmm.
Okay, we'll leave that. Okay, so second part of your FIS. Go ahead.
Oh, so that was all of the FIS questions.
Okay.
So I'm going to pop into the MSE part. Was there anything else about what I mentioned about FIS? Okay, so in terms of the MSE and the harvest strategy policy, when we met in June, I was saying that it seemed like the commissioners were intending to continue to apply annual discretion in terms of the coastwide management strategy, as well as the distribution to the regulatory areas. And Dave had asked us, have we actually heard that directly from the commissioners? And I couldn't say that I'd actually heard it specifically from them all in an open or in a meeting. And now I can confirm that, yes, we have heard from all 6 commissioners that they intend to apply their annual discretion to adjust both coastwide and regulatory area management procedures. They note that they fully understand that this isn't the typical way that MSEs are implemented, and that it also increases the uncertainty in terms of the interpretation of the MSE outputs. But this is what they intend to do. And so given that, a question that came from the Canadian commissioners are there ways to improve the robustness of the MSE outcomes by adjusting, say, the way that we identify, the way that we word our objectives, the way that the operating model is set up? Is there, given that this is the end intended use, are there ways that we can take that into account on the front end of the MSE?
Okay. We'll consider that, I think.
Sounds like modeling the decision-making process.
We'll talk about that.
Thanks, Anne-Marie. So Pete's not available for this meeting, but I believe he's passed the hat to Kurt, who is also online. So if we give the microphone to Kurt Iverson, and keen to hear any updates from you, Kurt.
Can you hear me now?
Yes, we can.
Okay, thanks. I believe Pete sent an email to the staff that reflected some input from the U.S. delegation of the commissioners. And if you have that handy, you might reference that. That was their sole input to this particular meeting. And again, it goes back to the FIS and a lot of the same things that Anne-Marie just talked about. This of course is in the front of everyone's particular chores, trying to work through increasing costs and what are acceptable levels of surveys that are going to get us through this. So that was essentially what they gave us, without a lot of more specifics than that. And I don't know if you have Pete's email in front of you, but maybe you could read that to the group.
Yeah, sure. Thanks, Kurt. In that email, the only pertinent sentence was, there's a high level of interest in what the SRB will discuss as it pertains to the FIS and the situation we find ourselves in.
Right, right.
Good. It's efficient. We will discuss it.
So I don't have anything more to add than that.
Okay, well, thank you very much. No questions from SRB? Follow-up?
No, I think this is what this meeting is going to focus on for quite a while. So.
Okay, well, moving on to agenda item 4, and agenda item 4 has as sort of the umbrella document is the 5-year program of integrated research and monitoring. We are working on the updates that you requested of us last meeting, and I'll just remind you that the paragraph 14 of the previous report, the SRB requested that the 5-year program of integrated research and monitoring be revised by SRB026 to reflect changing priorities in light of major progress on biological research and ongoing monitoring challenges. So we have started that process. We hope to get that completed by SRB26, or we will get that completed by SRB26. So my only recommendation there is to move that from a request to a recommendation for this meeting, and we'll just carry that forward. That way the commissioners also are reminded that this is occurring, and if they have any specific updates at the interim or annual meeting, they can also add those recommendations. And so that's all we have for that item. There's no specific updates to the actual plan for this meeting. Any questions? If not, then let's jump into agenda item 4.1. So 4.1.1 is the Pacific Halibut Stock Assessment. Dr. Stewart is going to run us through that.
If I could be promoted to presenter, please. Thank you. Okay, so I'm going to provide an update on stock assessment development over the summer following the June meeting, and a little prospectus on what's left to come this fall, as well as what we have currently intended for development for the full assessment next year.
Is it possible to make that full screen?
Oh, yeah.
Can you make it, or?
Oh, I can't do it.
If not,
There we go. Okay. So, as I said, I'm going to go through just a brief review of the stock assessment review process. I'm going to focus on the SRB requests, primarily the BIS design evaluation simulations following the general self-test assessment simulations you saw in June. I'm going to describe a little bit the treatment of aging imprecision and bias in the stock assessment, which was actually a recommendation that was made by you all in tandem with the other comments on the AI project, just to sort of orient us to how I'm treating aging imprecision and bias in the stock assessment and how AI may fit in there. I also, Joseph's group provided me with some preliminary results from some of the maturity investigations that are ongoing, and I ran a quick sensitivity just to give us an idea of how this may or may not affect the stock assessment, noting there's lots more to do before we actually would integrate this into a full stock assessment. And then I'll go through the topics that we're planning for investigation in the 2025 full stock assessment. So Dave already covered this in part. With regard to the stock assessment, we plan a full stock assessment every 3 years. And so this year is an update, with next year planned as a full stock assessment. As Dave mentioned, in June, we primarily focus on the research and development with recommendations primarily to the Secretariat. Now at this September SRB meeting, we are finalizing the assessment and planning for the next one. So following this meeting, I won't be making any, unless you have strong recommendations, I won't be making any more changes to the model structures, but holding things constant and then planning for the full stock assessment. So the recommendations here are both to us, if there's anything we need to adjust for the final stock assessment, and then directly to the Commission for potential use of this information. So I won't read your recommendations from the previous meeting, but basically these all pertain to the BIS design simulations. And again, as we had in the last meeting, we're going to have a lot of overlap between what Alan's done, what Ray's done, and what I've done. And it might there are different ways we could have presented it. We could have started with Ray and then gone to me and then gone to Alan. Any way we do it, we're going to have to kind of go back and forth over these topics. So we're going to start with me today. To reorient you, the proposal that I made in June was to basically to test 3 SPIS designs by a simulation. And these are the same 3 we've been talking about for the last couple of meetings. They are the top one, the base block design, is essentially, this is where we'd like to get to. If we could do this every year with a rotating block design, and Ray will have some maps of some of this stuff, we would be set. We would have all the information we need for all the various levels that the commission uses the information. Stock distribution out to individual regulatory areas, biological region, biological data from each of the biological regions. And as a consequence of both of those things, we always end up with low coastwide CVs. The other 2 designs, the second one, the core design, would be basically just biological regions 2 and 3. This would have some potential for bias because there would be portions of the geographic range that we would not be sampling for a number of years in a row at the ends of the distribution. And this is, I think, where we need to, I know the commission is still struggling with this concept of what's an appropriate CV. I think we've by and large moved past that question to, when we look at these reduced designs, it's not a question of the CV. With the space-time model, we can maintain a fairly low CV, even with a pretty sparse design. But what we don't know is how much bias could be creeping in. And it really, I think, is going to come down to how much potential bias are we willing to risk, realizing that we can't, that's what we can't detect. We can statistically define what the CV is, but what we don't know is how biased things are getting. And so that's, as you'll see, that's what I focused on in this simulation is well, there's one CV test, but most of it is focused on potential for bias. Finally, the third design, the reduced core design, this is essentially what we did in 2024. So this would be just fish a couple of the money-making areas in the middle of the stock distribution. We get some biological data, we get some information, we can sort of string things along, but the potential for having a different trend than we're observing is very high. And I think especially after this year, continued years of this, we are going to have lower and lower confidence that we're actually tracking true stock dynamics.
Yeah, just this may be something to talk about with Ray later. It seems like 2 and 3 are not necessarily simple types of biases here. Like those are, especially the reduced core, is why you get hyperstability fisheries CPUE.
Yes.
The core, similar, maybe not as drastic, but so the type of bias that could be created is something that should be considered.
Totally agree. And with the space-time model, we can have these reduced designs and we can come up with a coast-wide trend estimate that reflects the missing areas. We can propagate that uncertainty, but it doesn't capture the bias, and we don't have a way currently to correct the age composition information. So the biological information that we get from a reduced design we're currently not able to correct that in any way, or even to account for the missing geographical areas. So with those 3 designs, we set up 3 tests. And again, this is a review of the design that I presented to you in June. The 3 tests are really, the first one is, what's the effect of increased CVs? So in this case, all 3 designs are assumed to be unbiased. And we compare the reduced designs to the block design to see, well, what is the effect of basically having an increased CV? Ray did the work with the space-time model to produce the CVs that would be associated with these designs. And so then I can put those into the stock assessment. And then for the reduced designs, as you'll see, I think I've got my next slide, I'm also proportionally reducing the age composition information. But in this first test, I'm not adding any bias of any sort. So all the data sources are still unbiased. And we had to pick a trend for this design. So we picked no trend so that we could just focus on the CV. The second 2 tests are, what if we fail to detect a trend? And so the first test is the true trend is increasing. But when we look at the reduced core and the core designs, we've simulated data from a flat trend. And we're comparing that to the truth, which is an increasing trend in the FIS. And this is a 15% trend over 3 years, which It turns out the more we look into it, this is probably a pretty moderate level of bias. It's possible that we could have more rapid bias than 15% in total over a 3-year time period, but we had to start somewhere. So I would say this is a moderate to maybe even slightly weak test in terms of where the bias could actually end up. The second test is the inverse of that. So the second test is the true trend is 15% down over 3 years, but the 2 reduced designs are no trend. The data for the FIS is biased and estimated from models that were fit to no trend. So it may not look like it, but this actually took a lot of model fitting because I had to fit models to all of the combinations of data and true trend, and then mix and match the data files to create the files that fit to then summarize for the result. But doing the self-testing in the spring, we had already built the framework to do this. So it was really just doing the same sort of self-testing, but then mixing and matching all these various pieces of data. So I'll talk through a little bit how this works. So we set this up for the next 3 years, so 25, 26, and 27. We fit models to all of the true trends, stable, decreasing, and increasing. We also fit models to biased trends. So that would be models fit to a stable trend. And then we use that FIS data in models where the true trend is either increasing or decreasing. Bootstrap 100 new data sets from each combination of design and bias, and then combine those back based on based on each of the tests that we're in. The important part here is that the FIS trend and CV may either be biased or unbiased, depending on the case we're in. The age composition for the FIS was scaled with the FIS design, and so I didn't do this in a terribly sophisticated way. It was basically just a number of charter regions, which are roughly 60 to 80 stations large. I multiplied the average coastwide sample size by the fraction of the charter regions to scale down the age composition.
Into the age composition data, are those stable, or are there trends in age comps?
So that's a really important aspect of this, which is that this whole simulation was started in 2025, and so the current age structure leads into the simulation. And so when we get, for example, an increasing trend over the next few years, the model is going to explain that with some increases in recruitment. So the bias data sets won't have that information in there.
Bias data sets.
Because the bias data set generated from a flat trajectory where you wouldn't have it.
Gotcha. So the age composition data are also misleading.
They are. Yes, they are. They're going to be just as biased as the index. Now, that said, we're biasing the trend over a 3-year period. So most of the age composition is going to be, there's a lot of inertia already. It's not going to go that bad in 3 years. It's basically the summary. So the other important thing is that the fishery data in these cases I've always assumed is unbiased, and that it may or may not be true, but that's an important caveat here that we're not assuming the worst case scenario where we also have some bias in the fishery data. We're assuming the fishery data is always unbiased, and that serves to steer everything back, especially as we get to sparse survey designs. The model relies more heavily on the fishery data. The fishery data is unbiased. So in some ways that offsets some of these reduced FIS designs, as it might in reality, or it might not. Again, that's another uncertainty.
When you say the fishery data, you mean the fishery CPU?
The fishery CPUE and the fishery age compositions themselves. Yeah. And we've maintained that roughly this. I just took the average sample size and CV from the last 3 years and applied those moving forward. So we're assuming that fishery sampling stays the same and that it remains unbiased over the next few years. So after we've made these Frankenstein data sets with biased and unbiased components, we then refit 100 models to each of the combined data sets and then summarize across each FIS design. And we took these all the way to the estimate of spawning biomass at the end of this 3-year period, so the beginning of 2028. The level of fishing intensity estimated in the 3rd year, 2027, because that's the last year that we're fishing in this simulation. And then also looking at the probability of stock decline estimated in at the beginning of that last year. So basically, the models are developing a trend. We see how well do we estimate that trend in spawning biomass at the end of this 3-year bias period. So here are the results. The first experiment, how does the increased FIS variance during this time period affect the assessment results? The answer was almost not at all. We were within 1 or 2% of the estimated spawning biomass at the end of this time series. We have an unbiased estimate of SPR to the nearest rounded percent. There was no bias there, and an unbiased risk of stock decline. And the more we looked at the results, we realized that this is basically because, especially with regard to the spawning biomass, very few of these recruitments within 3 years, very few of those fish are going to actually be entering the spawning biomass. So almost all of this is informed by fish that are already in the pipeline and have already been estimated to some degree of certainty so far. So a little bit of extra variance in the FIS really doesn't cost us much in over 3 years, assuming there's no bias in any of the data sources going into the model.
But isn't it a bit risky? I mean, it looks almost too good now, and that's because the cohort's already there. But if the message we give is that there is no bias, and then it almost sounds like, yeah, you can continue with the reduced FIS.
Yeah,
And the problem will pop up at some point.
absolutely. And so I think, one, these are short term.
Yeah.
This is only 3 years. And so honestly, if there isn't a bias showing up in our data sets, if we have a reduced FIS for 2 or 3 years, it's not the end of the world. And I think that is a reasonable conclusion. But if we were to continue this for 5 years or 10 years, the chance that we would remain unbiased over that time period, I think is low. So you're right. This comes with some very strong caveats. That this is a very short-term look, and it's really set up by the fact that we're assuming that starting in 2024, we don't have any issues. There's already bias in the models, which there could be because we've had a somewhat reduced design for a couple of years. Then things could go south on us much quicker than this.
This is the ideal case.
This is the ideal case.
You're going to reduce it. This is like the best you're going to do. But part of the decision table, like the way they use this information, is they use, among other indicators, the probability of decline in their TCY decision.
Yes.
So this doesn't have zero impact on it because it increases the probability of decline because of the higher variance. So you're unbiased, but you're going to have a higher probability of decline just because of the increased uncertainty.
Well, it didn't come out in this case. So the ensemble of 100 models with increased variance actually got the right risk of stock decline at the end of 3 years. So that uncertainty didn't propagate into a difference
For
in
each quota option, for each TCY option?
No, I only looked at the
So you're estimating the trend.
Right.
But this is the projected, like the decision the information they use for a decision is the projected probability of decline.
I didn't do a full decision table, but I did the projected probability of decline if they were holding the coastwide mortality constant over this 3-year time period. So it is pretty analogous to what they would be looking at, but not at the tails, only around the decision point. Again, we're not talking, you recall from Ray's presentation, we're not talking about massive changes in the coastwide CV. We're talking about the coastwide CV going from 4 to 9% over 3 years. And so again, it's really, I think we're moving past focusing on CV and being much more concerned about the potential for bias creeping in these estimates. Because in the reduced core and core designs, we're talking about only sampling a fairly modest amount of the total geography that the stock is on. So again, this is the best case scenario. The second test here, so now the true FIS is increasing, but we failed to detect it. So these models are fitting to trend information that's constant, that's flat over 3 years, but the true trend is going up. So the fishery data reflects that increasing trend. In this case, we got a directional signal that we would have expected. So the stock is increasing, but we don't detect it. So we have a negative bias in the spawning biomass. We're underestimating the spawning biomass. And that bias goes up slightly with the reduced core design relative to the core design. we overestimate the fishing intensity. So the SPR goes from 47 to 46%. So we think we're fishing a little bit harder than we thought than we are in truth in this simulation. And we overestimate the risk of stock decline. So for the same quota, the true risk of stock decline is 40% in the base block, the fit to the base block unbiased everything model. But these reduced designs provide an estimate of 46%. Now, it doesn't sound huge, but you'll note in the text, I didn't include it in the slide, but in the text, a 1% change different in SPR is something that they have considered in their decisions. And that in the recent years, on average, that's corresponded to about 1 to 1.5 million pounds of TCEY. So if they wanted to say, well, we want to be robust to a 15% difference, so we're going to back off by 1% of SPR, that's going to be about 1 to 1.5 million pounds, which is around $7.5 million worth of commercial catch. So that's fairly large. The caveat there is that that's a short-term loss, right? Presumably, if they left those fish in the water, at some point, some of that yield would become reavailable to them. So it's not really quite fair to say they're going to give up those fish forever. But in the short term, to be precautionary to this level of bias, and I think this is kind of the calculation you all were suggesting in June, to sort of turn this into, well, what would this mean to next year's decision? It could mean something like $7.5 million of foregone yield in the short term.
I think you just apply the mortality rate to figure out what the immediately foregone yield.
You could. I think better probably wait and see what Alan's done in the MSC and look at the long-term effect of these things. But yeah, we just didn't want to take that conclusion too far because you're right. There's some difference in yield. The other complicating factor is that yield, if you think about giving up fish in individual regulatory areas, the fish may not be in those areas in the following year. They may have moved. And so it's not as simple as, well, you saved fish this year, you get them next year. You may not get them. Right, exactly. So the direction went as we might expect here. The third experiment, so now the true trend is decreasing, but we fail to detect it. So the biased FIS data are flat, but the true FIS information should be going down by 15% over 3 years. So now we see the reverse pattern where we overestimate the spawning biomass in both designs. And you see it is not quite, they're both 2 or 3%. And the reduced core design wasn't necessarily worse than the core design in this case. The true SPR was 44%, and both designs underestimated the fishing intensity. So we estimated 45% SPR, and we underestimate the risk of stock decline. So the true risk of stock decline in this case was 65%. So the true trend is downward, but both of the reduced designs estimated that probability in the terminal year at 56%. So it did a similar calculation there and said, because this is another metric that they often use to gauge their decisions, and said, well, in recent years, what would it have how much quota would have had to be left to adjust the probability of stock decline by 9%? And that turned out to be about 4 million pounds over the last few cycles, which is more like $24 million. So this is now, in order to avoid, if the true trend were going down by 15% and we didn't detect it, or 15% more than whatever trend we had, then they would essentially have to back off by about 4 million pounds in order to be precautionary to that potential bias in the short-term horizon.
Ian, can you explain why the bias is higher for the
Yeah, I think it's because the fishery data start to, because the reduced core design has a higher variance, the model fits it less and follows the fishery data more. And in fact, I think that's my next point here. Yeah.
That makes sense. Yeah,
So
it's not following the bias data.
right. So it leads to this somewhat counterintuitive result where you might think that if you're going to have a bias survey, you ought to have a bad one because it's got a bigger variance and it won't drag your model down. But in fact, the worse survey you get, the more likely the bias is there. So I think this is kind of a non-result in that you don't actually want a worse survey because your chances that it's biased are higher, even though its effect on the model is lower. The lower weight that survey gets in the model. And again, this is assuming that the fishery data remain unbiased. All these cases. So the fishery CPUE and the fishery ages are reflecting the true trend. And this is, if we truly believed that we always had an unbiased CPUE, we wouldn't need a survey at all. The reason that we have a survey is because we understand that there are conditions, sometimes transient, sometimes over fairly long periods, where the fishery trends can reflect things other than population trends.
Yeah, what's the potential for relaxing that assumption that the fishery independent CPUE is unbiased in a way that's not just totally arbitrary?
Well, so we fit in the models, we allow fishery catchability, we allow a random walk on fishery catchability. And the degree of variability is tuned to the amount of drift we've seen historically. And so what that means is that over the long term, we're pretty robust to changes in the fishery. We do have a few events like the change from J hooks to circle hooks. We allow an unconstrained offset in that year because we know that was a huge change. It doubled catchability overnight. The rest of the time series, we allow a drift in fishery catchability. And what that does is, in this case, though, it sets up the case where there's no information to tell it to drift. So it's just sticking with the trend, and we've modeled the trend as true. So I guess, we could set up a scenario where we tried to model drift in the fishery CP and catchability relationship in the future. And that presumably wouldn't perform as well depending on how we set it up. Obviously, if the fishery were drifting in the same direction the survey bias was occurring, it would make this worse and vice versa. Yeah. So there's so many assumptions. I feel like at some point we sort of get out what we put into these simulations. But at least I think we've been able to turn the concept into something that links directly to the quantities that they're looking at, which is what do we think the SPR is going to be next year, and what do we estimate as the probability of stock decline. So those are we've been able to translate it all the way to those end quantities, which are going directly into the decision-making process.
Are there any meta-analysis or anything like that that could be searched from the literature that would give an idea of how much the fishery-dependent surveys actually go off? Probably not.
There are a few meta-analyses on average variance for surveys in fishery CPUE series. Chris Francis did one years ago.
I think Sheldon Harley's classic meta-analysis
Yep.
that is pitched as hyperstability,
Right.
but it also includes estimate of
Those could give some informative priors to test the robustness.
I think one difference between these experiment 2 and 3, if you, in experiment 2, you had foregone some harvest and it cost $2 million, $7 million. That, and then you mentioned that can be recuperated.
Right.
This one is the opposite, right? You don't recuperate these.
Right.
And these actually accumulate. So that the more this happens, the deeper you're digging your hole, basically. So that.
And presumably, we don't find out how deep the hole is until we do a big survey design again. Because it takes a full reset to understand how biased we've gone. You have to actually go to those areas and see, the model was predicting no trend here. And look, the trend actually was going down the whole time we weren't looking.
Basically, the conclusion would be that for 3 years, it's okay to do reduced fish, but then it needs to be followed by a full.
Yeah, even over a 3-year time horizon, if they really wanted to be robust to the potential for bias, they should probably be more precautionary, or even over a 3-year horizon. But yeah, the conclusion is it's not going to go horribly wrong in 3 years, but then it would take basically a full survey again to get us back to being confident that we had an unbiased estimate of where the stock was.
Ian, following up on your point about, eventually when we do the full design, we find out that it's these fringing areas, things have collapsed. I think that 2 or 3% bias sort of, which is for the overall, right? I think that underestimates the effect in these fringing areas. So it'd be interesting to look at what that means for, regions that where the bias is creeping in, right? The core area, it's pretty steady and it's pretty. But in some of these fringing areas, you can get a situation where they've, for a couple of years now, they've overfished the regional ones. And when the survey catches up, then you apply the distributional algorithm that they use, you could have a shutoff in those regions, right? TCY could be
And
really,
that's-
really low.
Yeah, you get bigger adjustments when
Yep.
you do it.
And that's exactly this sort of circular discussion we've been having that Anne Marie brought up, that the commissioners are asking us, well, what CV do we need? And we say, well, it's really not about the CV. It's about the potential bias. And it depends where you want to use that information. Because if you want accurate estimates of each regulatory area to avoid this situation of a giant catch up at some point, then you don't even worry about the CV. Just worry about getting an estimate in each regulatory area so that we know that we're not going to have a huge offset to get back to a stock distribution estimate. But so far, we've not gotten clear guidance on the degree to which the commission would like to use stock distribution to inform their distribution decisions versus using other tools. So it's hard for us to prioritize because what we've said is if you want to estimate the stock distribution by regulatory area, you need to sample in each of these areas with some reasonable frequency. But if you don't, then our coastwide trends are robust. For example, 2A only represents 2% of the coastwide biomass. We could skip that for years on end and be fine at the coastwide level. But as you point out, when we went back there and looked, we might find that we were grossly over or underestimating the local abundance in that area. So that's where we're kind of caught. It's we build models to answer questions, and we're not 100% clear on the question that we're supposed to be answering at the moment.
Well, but I think that's iterative, right? You can also build a model to sort of indicate where they should be looking for problems. So you don't need to know the exact procedure that they'll use. It sounds like they want people have flexibility there, but you can use some reasonable hypothetical procedures and say, look what happens in 2A.
Yeah.
You're going to coast along doing fine for a while, and then you'll finally do a full FIS design, and you'll see you have to close the fishery there.
And that's something we've been working on, is looking at the historical change in these areas and looking. So if you saying, okay, if we go back in history and look for any 3-year period, how much did things change? So that at least you know that things could change by at least that much. And that's assuming that the current dynamics are equivalent to what happened historically. So that's one avenue that we've been going down, is trying to turn this into more of a retrospective look to say, if we hadn't gone to 4B for 3 years in a row over time periods when it was changing, how wrong would we have gone?
Yeah, I like that approach, but I think it does underestimate the changes that could happen, right? Because the past is under a condition of pretty good information.
Yep.
And if you start managing under poor information, you can see bigger changes in places like 2A.
It also doesn't have the feedback of a mismatch between the harvest
That's
and
what
mortality.
yeah.
Right. So presumably we had a decent idea of what the abundance was during.
So you start fishing it for a few years without it, change is bigger. And a 15% change in the stock-wide abundance implies much larger changes in these other areas, right?
Yeah.
Because presumably you do have stability in the water.
Yes. So it's not too hard to summarize in 3 slides, but that was actually a considerable amount of model runs and work to put that all together. It was hundreds and hundreds of simulations combined together. And I, as I mentioned in June, I don't want to understate the importance of the FIS in terms of its effect on everybody's confidence in the whole process. When we show up at a meeting and we've had a design, so this was our design this year. And so people, someone who owns quota in 4A or 4B is going to look at this design and say, how do you have any idea what the trend is in my area? And the answer is, well, we have some idea because we estimate the temporal autocorrelation in trends, but the reality is, if it's been 3 years since we've been to 4B, we don't have a lot of idea what's going on. And this is something that's not easily captured in a statistical simulation, but it's very real to our process. We actually had, I mentioned it in June, we actually had a regulatory proposal last year. Preliminary, I don't think it got re-upped at the annual meeting, but one of the proposals that was floated early in the process was to freeze allocations to areas that didn't have a survey, which makes some sense, although it only makes sense if they're adjusting the coastwide yield, because otherwise those fish just get caught somewhere else. It may not be the right place to catch them either. So
Freeze allocations, meaning keep them constant.
right,
Well,
The
that's
TC.
not really robust to it.
right, exactly. So there's it's not, but I think it illustrates the concern people have when, for example, quota owners in places like 2A and 4A and 4B that didn't get any survey last year are going to be wondering, well, what are you basing our quota on?
How good is the fishery dependent data?
It's
People are fishing there.
it's
enough?
pretty sparse. And in fact, 4B is kind of a unique case because in recent years, due to the price of fuel, the price of fish, and probably the catch rates at 4B, there's been a lot of quota left on the table out there. They're not catching all the quota, anywhere near all the quota out there. So it's hard to know whether the catch rates are really reflecting what's going on. There's a lot of that area, especially in the western part of 4B, that people don't really bother to fish. There might be some incidental halibut caught while they're catching other things, but it's not worth driving hundreds of miles up there to come back to Dutch Harbor and get $3 a pound for halibut. It doesn't pencil out.
To what extent does the industry use the results of this? Are they deciding where to fish at all with this, or is it much more their own experience?
We're aware of some cases where, so we publish the station by station information, and we're aware of some cases where, especially for new fishermen entering the fishery, they might look at our maps and identify some areas of higher catch rates, particularly in areas where catch rates are really clustered, like 2A. There are definitely some areas that you can see in our data that turn out to be pretty good spots. They're not necessarily the spot within the spot, so they'll indicate a good bank. But then the guys who are really good will know the spot inside the spot. That's even better. But they definitely use our survey information to some degree. I think we do spend a lot of time in many years comparing the trends between the fishery and the survey. I know Ray's had at least 3 or 4 different years I can remember where there have been a mismatch in one or more areas. The survey goes up and the fishery goes down, or vice versa. And we do a lot of peripheral analysis to try to understand, okay, if we winnow down to just the fishery during the same months as the survey and the same stations, do we get the same trend, and or is there a difference in depth or timing? Or we've done a lot of that sort of stuff. And generally, the fishery CPUE and the survey CPUE kind of match up over the long term. But there are definitely years when one will go up and the other will go down, or vice versa. And we spend a lot of time talking about it, and we try to remind people that both of these things have CVs on them, and just because one goes up and one goes down doesn't mean they're not still referencing more or less the same thing over time. Okay. Yeah, I think that's all I had on the design simulation. So why don't I continue on? We can look back to that maybe also after you've heard from Alan and Ray, because like I said, we're all working on this topic from various angles. So the next recommendation was really with regard to the AI project, but the 4th bullet there, the importance of different aspects of aging, accuracy, and bias in the stock assessment, I thought it would be useful just to reorient you to how I'm treating aging and precision and bias in the stock assessment. So currently we have 2 aging methods that are used in the stock assessment. We have surface aging, which is biased for older ages and less precise. That was the standard method that the commission used up until 2001. In 2002, we switched to break and bake for all of our otoliths, which is unbiased and quite a lot more precise. This break and bake method was validated with bomb radiocarbon methods early, about 20 years ago now. So these are known age fish, and we measure the bomb radiocarbon signal from nuclear testing, and we know at what age the fish was aged at and what year it was collected, and we know when the signal from the nuclear testing occurred, and so you can validate the ages using that method. I think that's kind of the global gold standard for age validation if you don't have direct known age fish. Within the first few years that I was here, we did a series of double reads between break and bake and surface ages, and also double reads on the break and bake aging method. So we have had in certain time periods up to 4 agers here. And so we can have them each read the same fish and then compare to see the ages that each one of them reads. And then from that, we can estimate the degree of imprecision. This is done using a program that Andre Punt wrote, which actually includes the conditional probability that when you get 2 readers age a fish, they get the same age, but it's not always the right age. They could both be wrong. So there's all those conditional probabilities of 1 right and 1 wrong, or 1 wrong and 1 right, or 2 wrong, or both of them got it right. So it's a pretty complex estimation, but you can input all the double and triple reads and quadruple reads that you have, and get an estimate of what should be the true age composition and the true imprecision, accounting for basically the errors and variables of having multiple readers. What we end up with is shown here. I did it using Andre's program. Bill Clark, 20 years ago, did it using an empirical approach, which didn't quite have the same probability of both readers being wrong, but because he had so much data, the dashed line is his estimate of imprecision, and it was actually really close. And for this method, this is pretty precise aging for a marine fish species. I mean, we're only off by a few years, even out to 25 or 30 years. These ages are really good. Our aging lab is incredibly consistent, and part of that is because they do a fairly large QA/QC read every year, and not only do they double read, but they check each other, and sort of keep everybody on the same page. The other thing we have going for us is that Joan has been doing our aging for 32 years now, and she's probably aged hundreds and hundreds of thousands of fish. So she's incredibly consistent and precise and accurate with her aging. The surface ages, when we compare them, so you can also use the same program to estimate the degree of bias. If you have one unbiased method and one biased method, you can estimate a functional form for that bias. And so this is the results of that. Age method 2 in this figure is the surface, is the central tendency of the surface reads. So it's true age on the bottom, true estimated in this statistical method, and the mean observed age in the y-axis. And so you can see that the surface aging, method 2, becomes increasingly biased after about age 50. And so we deal with that in 2 ways. One is that in the stock assessment model, I take all the surface ages and I assign them this method. So the central tendency of those ages is known to be biased in the stock assessment model. And then to deal with that even further, I use a different plus group for the data. For years when I have surface ages, I put the plus group at age 20. And for years when I have break and bake ages, I put the plus group at age 25. So by moving the plus group down, if this bias is a little bit off in one year or another, it reduces the effect of that. So it just aggregates all the fish to 20 plus. It does leave information on the table about the right-hand side of the decline of those cohorts for years when you're dealing with surface ages. So it's nice to have the break and bake age to get a little bit more information out of those older fish in the years when we have break and bake.
What fractions of the catch are we talking about out past 20 years?
Not a lot. Most of I think historically, approximately 85% of the commercial catch is between ages 8 and 16. So by and large, these fish are caught by the time they're years old.
So the bias, that's not like time dependent, so that it sometimes gets biased one way or another.
It seems
fairly constant.
It seems to be quite consistent. We actually, as part of this estimation that we did, we went back and re-aged 500 otoliths from every decade, from the 70s or the 90s, 80s, 70s, all the way back to the 1920s. And then we did some runs where we estimated a separate aging bias for each decade, because we had the original age reads and we had the re-aging. This was done, I believe this was around 2013 or 14, and we compared each decade, and what we found was that it had been pretty consistent over time. And to Joan's credit, when we started this, and I was asking for like another 5,000 odorless age, and she said, you're not going to find anything. We've been consistent over this whole time period. She was dead on. We didn't find anything, but I said, look, we just have to do this. At the time, we were mainly doing this because we were concerned that some of the changes in size and age that we had observed, I felt like a parsimonious explanation for such a large size at age is that our aging method was true. And actually, the fish hadn't changed that much, but we were aging them at different ages. Really wanted to rule that out and make sure that we were dealing with a real biological phenomenon and not just an artifact of our aging methods. So that's why we went back and did this originally. But it also provided a really powerful data set to re-estimate all of the aging and precision and bias relationship as well.
Have you guys looked at length stratified aging methods? So below the length cutoff, just do surface aging because that's
They
lowest here and above that cutoff.
They do. I believe that maybe even still do some of the trawl ages for ages 2, 3, and 4. They just read the surface. You could literally hold them up to the light and tell it's a 3-year-old. So I think they actually still do some of that. What we see in the reader to reader comparisons is that right around maturity, so 10 to 12 years old, that the rings get a little tighter and a little harder to read. And after that, they really need to break and bake them to get that resolution, to get visual. Out there. So where this ends up in the model is that I have 2 age method definitions. I have break and bake on the left and surface on the right. And this basically shows you the transition. So the way this works is that the model is keeping track of the true numbers at age. And when we're going to fit to data, we take the true numbers at age, we multiply by selectivity. So we get a true numbers at age that we associate with a particular source, multiplied by selectivity. And then we multiply them by this relationship to get what we would expect to observe. Had this been the true age structure, this is what we would expect to see after we multiplied by these relationships. And so, for example, on the right there, you can see that if we had a whole bunch of fish at age 25, those fish would get spread out between ages 15 and 25 if we were, in order to compare to an observation that was using the surface aging. So it basically corrects the true information to create an expectation that you then compare to the observed data that's consistent with aging properties that we have in that case. And you can quite clearly see here how the surface aging, how the bias and the imprecision work together to mean that we really have very little information in the data after about age 15 in the surface ages, where we continue to have pretty good information in the break and bake information. And for the first few years there, you see up to ages 4 and 5, we essentially just get it. We assume that we're getting them all right. So what does this mean for the AI project in particular? There's no limit on the number of aging methods that I can have in the assessment. So that's totally generalized. And as long as I have comparisons between methods, ideally between the break and bake method and any new method, and a new method might be a particular AI model, as long as I have that comparison and I can create one of these transition matrices or these comparison matrices for the new method, I can include pretty much any type of aging method, whether it's really precise or not very precise, whether it's biased. We saw some evidence in some of the early AI runs that maybe it was getting a little biased for the older fish. Well, that would be a lot like the surface aging method. But what we end up with is essentially just a trade-off between the sample size, the precision, and the ease in creating these ages. Some of the considerations here are that the more imprecise the aging method gets, the harder it is to track individual year classes. And so the less information we've got in the stock assessment.
Just quickly,
Mhm.
The AI was trained to massive amounts of ages.
Mhm.
Did that include surface ages?
No, we also need
Just-
break and burn. We use the more recent, although it's
So
current.
it's not just reflecting that
Right,
bias, it's
right.
actually its own.
But it's worth noting, I think, that the AI is trained to the break and bake, and the break and bake isn't perfect. And so I think we would never expect the AI to do better than the method it's being trained against. It's going to have some error just because it's being trained on a data set that has some error. We don't have a true known age data set.
And we discussed also a little bit how this could be applied. There could be some sort of imprecision added to the AI. So each added to the AI model. But prediction with some sort of probability distribution. well. So there are ways to try to mimic the same precision. Support AI models, that AI model kind of learns from actually precise results as well.
So I see it as kind of a three-way trade-off. The more precise it is, the better we track year classes. The more biased it gets, the less information we have about older fish and therefore about the overall mortality rates. So if we use a lower plus group and or we have increasing bias and precision at the older ages, we just know less about the right-hand side of the catch curves. The flip side of that is a faster method, we may actually be able to generate more ages, have more information. And so the great fisheries fallacy is that the average of lots of poor data is some pretty good data. You know, if we have a whole lot of not great ages, that's better than just a few really good ones, maybe. The key in terms of thinking about moving forward with AI is that it has to be reproducible. So what we can't do is have a constantly evolving AI model and try to use the same imprecision matrix, because it won't be the correct one. So every time we update the AI approach and essentially change its properties, whether that's precision or bias, we need to create a new imprecision matrix for use on that particular data set.
Well, you could update the AI model and rerun it. Sweet, right? I mean, that's
could.
one of the benefits of
You
the
could.
AI model. You can go ahead and re-age
Right.
everything.
And in fact, that's the way we treat the age data. We reprocess them every year. So it's just run the R script to create the age comps, and we have a new and assign it the right imprecision matrix at the end of the day.
Normally, when we run the AI model, we start from scratch. So when you think about, you could save potentially time by kind of starting from the model, having the person train the model, that's adding images. But I think overall, it's much more cleaner process. We train the whole model. So just that. Also the indices that you can set them on that, depending on the number you started with, depending on how many you have.
Where it starts to get complicated is if you think about, if we do say half of our ages with AI and half with break and bake, do we combine those into one sort of composite method and estimate the properties of that based on, on comparing that to break and bake, or do we just treat two replicate age compositions from the same source in the same year with two different aging and precision matrices? There's lots of ways we can go about that.
I mean, it seems like there could be a lot of efficiency gained by using the AI and only break and bake the ones that the AI estimates sort of above a certain age, because you know that that's where the
Right.
AI is just guessing. Right?
Exactly.
But before that age, there's no point doing the break and bake,
Right.
because the AI gets it right.
But we would then have to validate that. That would now be a composite method. So we wouldn't be able to take the break and bake ages and use one age. You'd have an age composition that was developed from a method which was using both of those tools. And so your imprecision might be a little different. It might actually be wider and then narrower for the older break and bake. Who knows what it would look like? But we'd have to work through that process of the method this year is the 2024 AI model, and then break and bake for ages 15 and up. And that's the method. And then we estimate the transition or the imprecision matrix, and then we assign it to that year and use it in the model. So there's lots of ways we can do this. It's actually quite flexible.
Wouldn't it make sense to compare the methods of
Mhm.
deciding the age structure and actually make a proper scientific peer-reviewed paper, which you could then always cite, and you would get an idea of how much in the end product there will be uncertainty.
Effectively, we can go back and do like we've done with break and bake and surface.
Yeah, because
Define-
you have already
define all
done
the
the work,
properties.
so it's
Yeah.
just writing it up and
Yeah.
be a nice paper.
Yeah.
Useful for
We're,
others.
we're still a little ways out, I think, from having a big enough data set to go there, but yeah, I think that's where we're headed. And then, we can actually take this all the way to, we have duplicate data sets. We can compare the assessment results using break and bake versus using a method that's less precise but still unbiased, or less precise and biased. And we can do some of those tests. The thing is, it doesn't really tell you, it might tells you what the short-term sort of one-off effect is, but doesn't really tell you if we switch methods and we do the next 2 decades using AI, it doesn't really tell you how that turns out, that experiment turns out. So, the commissioners are undoubtedly going to ask us, is this new method precise enough to meet our objectives? And the answer is, it's hard to say. We can certainly fit models that use these data, but if it's less precise, we're giving up a little bit of information. If it's biased, we're giving up a little bit of information, but it's going to be hard to quantify just what that means. So that's the backdrop for the AI project. I won't spend a ton of time on this next one, but I did just want to give you a sneak preview. Yeah, go ahead.
We just take a quick 10-minute.
Sure. It's a good break point. Yeah.
Then on our next break will be lunch at 12:30. So.
So we'll be back shortly for those listening online. 10 minutes.
So that's the biggest part of this presentation. The other pieces that I wanted to provide are a preliminary look at the effect of the new maturity information on the stock assessment. Again, this is very preliminary. It's likely not what the final approach is going to look like. We just did something very simple here to get a sense of how this might affect the assessment. You're going to hear a presentation on the updated curves, the effect of the 2023 data, et cetera, from Joseph's team. But I just wanted to see quickly, how might this affect the stock assessment? So the curves, and I made them really small here so you can't see them very well, so that you have to wait for Colin's talk to get the full set of details. But basically this, with the combined data of 2022 and 2023, it suggests that more younger fish are mature than we thought historically, and fewer older fish. And further, we're fitting models to the maturity information, but all these models suggest some fish less than age 7 are mature, but we've never actually observed a fish mature at that age. So similar to the old approach, I just took the minimum age we've ever observed and set ages below that to 0 maturity as a first cut. This is very simple, and I want to highlight a couple of questions that we're going to have to think about as we think about actually doing this in a real stock assessment. So what I did in this case was I just took the historical maturity ogive and replaced it with the new one. But this doesn't account for any differences in the historical stock distribution. So they showed you that approach of weighting based on the different regions, the abundance in the different regions. I can't take the curve, the composite curve that's done by weighting, and then just sort of naively apply it to the whole time series without thinking about how the proportion in each region may have changed over time. We don't have estimates of that prior to 1993. So when we think about applying this to the whole 100-year time series, it becomes a little more complicated. Some things that we might want to think about are whether we can take the historical macroscopic observations and somehow correct them. So use the information that we collected over time, but correct it based on what we know now. Where and how we can account for variable stock distribution. We know there was a lot more of the stock out west, which at least currently has a different maturity ogive. So that's something to think about. We don't know whether that maturity ogive necessarily would have been different historically. We could also, in the stock assessment, rather than just having a single maturity ogive, we could make this a time varying relationship and actually use the stock distribution information we have back to 1993 and perhaps some kind of an average before that. These are all questions that are going to have to get answered before we do this for real. Nonetheless, I wanted to just get a sense of what this looked like. And it does, I think, sort of what you'd expect. We have more young fish in the mature biomass. And so it scales up the estimates of spawning biomass slightly. Not uniformly over the whole time series, because it does depend on the age structure of the stock as the estimates play out over time. It suggests that the true level of, or not true, I won't use the term true. Given this sensitivity, we would estimate a lower level of fishing intensity and a slightly higher status than we do using the historical maturity sensitivity. Basically, we're including a bunch more fish over the ages 7 to 10 that weren't in the old maturity schedule. So it makes the stock appear to be a bit more productive and the spawning biomass a bit larger. I was curious for individual models, and I looked through a bunch of results, but not really in depth. I just took one of the models and looked at the full time series. This is the coastwide long model, just to try to understand a little bit whether it had any huge effects that you didn't see just looking at the composite. So this is the ensemble of all four models put together. This is just one of the individual models, just to try to get a sense if there was anything there. Generally, the spawning biomass is larger over the estimate is larger over the whole time series. What it means in terms of recruitments, and it's a little bit hard to see here, but all the recruitments scale down slightly because you get the same, roughly the same amount of biomass for a smaller number of fish, because more of those fish are mature earlier. So nothing too unexpected here. And I think, I don't know, I haven't thought about whether to present any of this, but I think we're anticipating at least the question of, is this new information likely to cause us to, I think we're in a whole new conservation concern than we were before. I think the quick answer is no, it's probably a little more optimistic than the historical relationship, but there's a huge caveat that we have a lot still to figure out. And I think next year's full stock assessment is a great time to think through some of these other questions about how we integrate this information into the longer time series. And we'll have another year of data by then. We should have the 2024 samples in time for next year's stock assessment as well. So anyway, this is just kind of a preliminary heads up. And it's a little bit of the cart before the horse, because you're going to hear all the details from Colin later in this SRB meeting. So that's probably going to be one of the bigger pieces that we need to figure out for the full assessment in 2025. We expect to have this. This is now sort of a prospectus on things that we're planning to investigate. We should have the 2024 data available, and we're going to need to think about how to include this information, given those questions that I laid out in the previous slide. Some other topics that are both following up on the last full assessment in 2022 and in some regards new. We have used the Pacific Decadal Oscillation as a covariate to recruitment in the stock assessments for a number of years. We continue to retest that. There's now a new time series of PDO available, which is longer. It goes back all the way to the 1800s. So it potentially covers the full time span of these longer models. But it is standardized to a new mean period. And so the way we've used this as a regime of binary 0 or 1, depending on when you're in a positive or negative regime, because it's standardized to a different average, it actually changes the regime definitions a little bit. And so I think we need to explore that in the models and see whether that does better or worse than the current PDO index that we're using, and or whether having the longer time series improves the predictability of recruitment in these models. So we'll continue to explore that. We have a couple avenues that we'd like to investigate with regard to data weighting. So in the 2022 stock assessment, we introduced a bootstrapping procedure that I had actually developed almost 10 years ago for determining input sample sizes based on the underlying sample properties. Recently, Pete Hulson and Balen Williams extended that method to also include aging and precision. So I think this is a pretty nice extension of the work that was done in the past, and I'm curious to see how it affects our sample sizes here. So again, this is just the input sample sizes for starting composition data in the model. So that'll be something to add in the next stock assessment. There's been a huge amount of work done just in the last few years with some new diagnostic tools. The biggest one, I think, is an ongoing transition from Pearson residuals for composition data to one step ahead residuals. And I'm currently working with Paul Monahan on some ways to interpret one step ahead residuals, but I'm looking forward to using these approaches on this model to determine both data weighting and also to look for model misspecification. So I think everybody in stock assessment is kind of working on this topic right now. It'll be interesting to see where we get in the next year or so. We are also going to continue to evaluate the estimation performance of natural mortality. You'll recall from 2022 that we estimated natural mortality in the areas as Fleet's short model. We still have one model, the short coastwide model, where we have a fixed value of natural mortality. In previously, we've not had good luck estimating that value in the model, but I'm interested to look for, having gone through this quite a lot of investigation in 2022, I have some ideas about how it may or may not be confounded with the sex ratio and selectivity in these models. So I want to do some more investigation there and see which of the leading parameters it makes sense to estimate in these models and which ones we have information to inform. We've identified a few places where there are some pre-model data processing and analysis steps. We have some minor components like weeding of tribal data that I think could use a little bit of cleanup from historical scripts. And of course, as we dig into these models, it's a full stock assessment. We always seem to find some other topics that need investigation. We'll be working with Alan to identify things that have come out of the MSE that may or may not be worth re-looking at in terms of data and the way the assessment is put together. I know in the last, over the 2019 and 2022 full stock assessments, we've made several improvements that actually helped the MSE process as well. One of them was better use of the stock recruit relationships in these models so that it was easier for Alan to extract the results and use those to project forward. So we're going to continue to coordinate there as well. You will get an update on progress in June, and we will have, as usual, we'll have a summer iteration where you'll be able to evaluate each of the stepwise changes that we're proposing, if any, and give us your advice on whether they make sense or not, and additional things to look at. So we'll have a check-in in June, and then we'll be finalizing that information in September of next year. Let's see. I don't have a slide for it here, but we have noted to the commission, we had some discussion at the work meeting that the development of the stock assessment does depend on decisions the commission makes. For example, we've had, since I've been here in the last 12 years, we've had back and forth on whether we should make a larger effort to make these models fully Bayesian and make better use of perhaps informative priors and have true probability distributions coming out of them. If the commission were to decide on a 2 or a 3 year assessment cycle, that would all of a sudden become much more tractable to go that route, because we wouldn't need models that were able to be turned over as fast and or as robust to surprises in the data. So our model development really depends on what the commission's asking us to do with those models. And so we're certainly always looking to see whether or not the commission is going to make a change in how they are going to use the annual stock assessment, whether it would be, a multi-year stock assessment, or whether they move more toward a management procedure. I mean, at the extreme, a management procedure that was based on an empirical rule would allow a lot more room for detailed model development on the assessment side, because I wouldn't be trying to produce tactical information by year basis. Whether we're close to that or not, it's hard to say.
So you would use some other software or develop a new model, or how would you do this?
We could spend more time doing things like developing a state space model for halibut. We could spend more time developing spatial models that might be included in an ensemble if we weren't trying to do a tactical assessment every fall.
I'm sorry, they talked about the Bayesian.
Yeah, the Bayesian models. There's a bunch of things that we could explore that I think certainly would strengthen the whole approach if we were mostly using the assessment as a way to tune and check the operating model rather than as a tactical tool on a basis. But we're sort of always waiting to see what the next phase of commission decisions is going to look like.
Yeah, speaking about state space models, a lot of regions are working in that direction. Some of the next all the assessments are in mind. So curious about whether, without a change in the assessment cycle and the use of the assessment for is that something that is on the horizon, or is that just never going to be possible if you have to come up with an assessment?
I think it's quite on the horizon. The challenge we're in right now is that both SAM and WHAM, which are the two leading state space models, Neither of them has any split sex dynamics. Dimorphism is key to the element picture. So I've actually been in touch with Tim Miller to inquire about development on WHAM, and there's actually some work being done to extend WHAM to make it multi-stock, as I understand it, but that's potentially generalizable to be two sexes within a single stock.
It's already been extended to stocks. There's multi-WAM.
Yeah.
It's just used for black sea bass.
Yep.
It's only has 2 stock regions in it.
Right. And so I gather from talking to Tim that that's not far away from being able to have males and females in a single stock. But there are still some other, there's still going to be some other things to figure out in terms of that transition. But I could see us maybe within a few years having a fifth model, or even transitioning from some of these models to true state-based models. Certainly, it's on my list of things to be interested in. I don't see that being tractable for the 2025 stock assessment, but we'll see. 2028 could be possible.
I mean, currently, the 4 models in the ensemble, that's a great, really robust approach to uncertainty and how to penetrate the data. But you can imagine that the ensemble also includes some different assessment frameworks.
Absolutely.
That
Yep.
the state-based model doesn't replace
Yep.
what you have now, but it adds a new approach to that.
And what we have had over the years, we've investigated. We actually had a BPA up and running and considered that for inclusion. We had a custom ADMB model that was written just for halibut that we used for several years as part of the ensemble, along with 2 of these existing models. So we've had kind of a rolling composition of this ensemble. I don't think it would be at all an issue to include more models or to replace some of these models with, some of these models are sort of pseudo state-based models in that we have time varying processes that are just not treated quite right as random effects. So that would be something to investigate. Again, it's interesting to me that none of the applications of state-based models have done split sex dynamics yet. And to my knowledge, there aren't any that have a lot of ages either. They all have a fairly limited number of ages. I'm aware of a few applications that might have 10 or even 15 ages, but I don't know that anybody has done them out to, say, 30 true population ages. And so,
Meaning
Yes.
like a general package?
I mean, like even a one-off. Anybody
Or
estimating?
single fish model?
Do you have a full state space out to age 25 or 30?
35 plus?
Yeah. Okay. There you go.
Atlantic caliber one?
So you're going to have a huge number of random effects in those models.
Yeah.
You've got, I mean, if you can imagine a 100-year time series, 30 ages, any process that's being treated, all of those, the standard random effects are going to be thousands of parameters.
It's about 1100.
Yeah. So, I mean, I think we're rapidly catching up to the point where this stuff is pretty tractable. Do you have split sex dynamics as well? Males and females?
Yeah.
Okay. I'll have to look into that.
The shrimp model we just did, we're doing now. It's a full size structured model. So they're hermaphrodites. So you've got males transitioning to females, and it's got 2 areas. That's pretty well.
Okay.
Did Tim Miller mention when WHAM was going to be used for some flounder? That should give you an idea, I think, of when split sex is going to be.
Yeah, I'm trying to remember.
It has to be
So
there.
there's 2 efforts going on. There's Andrea, I think it's Andrea Havron and Cole Monahan are also working on adapting WHAM to some of the Gulf of Alaska stocks. And basically flatfish everywhere need split sex dynamics. And so they're also working on a kind of a parallel track on the WHAM code as well. So I wasn't clear from conversations with all of them which group was closer to finishing that, to bringing their branch back into the main WHAM code.
About Sam. Is that,
They have no interest in split sex dynamics in Europe, apparently. All their fish don't. Or for some reason, they just don't seem to.
it doesn't matter.
I asked Anders about it. He said, no, we don't do split sex dynamics. So, I don't know. It's presumably some of their flatfish could benefit from it, but so far they don't do that.
It makes a difference when you're running projections and stuff.
It makes a huge difference. I mean, for us, the catch is 85% female. So it's just, that's dynamics we can't ignore. We absolutely
That's
have
why
to
we
have
did it for sablefish,
Yeah.
because females are much bigger.
it. It makes a big difference. So, and we're also tracking the developments of FIMS, which is the next generation NOAA model. I think like a lot of groups, we periodically get in touch with Mark Monder and Alex De Silva down at the Tuna Commission to see what their plans are. They are planning to stick with stock synthesis for the moment, for at least the next few years, similar with the IPHC and some of the other groups. We're just kind of, we keep track of who's using which platforms. And we have this long running discussion about whether we'd be better off with a custom model here or whether we'd be better off with a general model. It's an open-ended discussion. There's a lot of pros and cons to both. So,
Is it something you can get some funding to just try? Fund a student to write their postdoc?
yeah,
In-house model, custom
Yeah.
model.
potentially.
That's what we did with the MSE operating model
Yeah, no.
programmer for a year.
I mean, I guess they're writing, I think it's already in progress, the RTMP. So it's not like somebody has to go and through all the hassle of writing raw TMP code now.
Although, what's available at this point in RTMP?
It's limited to some degree, but
Yeah, actually,
fast.
I actually participated in a class with Anders and Sean Anderson last spring looking at RTMP. And in a week, we were able to code up some simple state-space models and some simple spatial geostatistical models. It's incredibly powerful. Really impressed with the tool. It's it's one of those things where it's not a huge task to get 80% of the functionality we would need, but that last 10 or 20% is going to be a huge lift because we just have so much complexity in the hell of the data sets, multiple everything.
That 80% will happen faster than it would in another platform. But the
Right.
remaining 20% just adds that functionality.
Yeah.
Yep. The timeline for that. Be really careful.
Although they all seem convinced at this workshop, Anders included, that TMB was dead. It was all going to be RTMB from here on out. Casper was going to put all his effort into RTMB, and by the time the dust settled, there would be nobody would be writing in TMB anymore. See,
The one thing about a custom model here is it's one, we end up mimicking a lot of other models when you build your custom model. Follow what they're doing as they work, you're sort of on parallel tracks. But the other thing here is, we have a limited staff and the maintenance of that model and the updating of the model. And that's what I'm sort of finding out with the MSE operating model is my time to get in and recode the stock recruit function or whatever. It's like, oh, when am I going to be able to do that? These generalized models, they have these groups of people that are working on it, and you can submit a request and often somebody else will do it for you. And so that's one of the trade-offs, the benefits.
Yeah, I think I'm less excited about a custom model. Sean is for that reason exactly. You've got a larger community with things like WAM, and I would encourage moving to emerging stock assessment platforms.
Yeah.
That seems to me to be a way of making advances without having to code your own model.
Yeah.
And you need to maintain that expertise in-house. If that expertise goes away somehow, finally decide to go hunting full time.
making sure that the platforms are something that a modest number of people can jump right in and use immediately. Yeah, it's certainly a trade-off, though. I mean, we've discussed it pretty consistently over the last 10 years. It's not obvious that one or the other is the better choice for us.
And the benefit of what we're using now with stock synthesis is Ian and I are both intimately involved with that program, and we have the ability, if we wanted to go in, make changes, but we also know the people working on it, convince them to make the changes that we do stuff in. So it might be more of a becoming more involved with the different groups working on these different generalized models, becoming part of those groups. Because I would love to do some coding, but it's just in my spare time.
Yeah, I think a comfortable middle ground is using stock synthesis, but being open and exploring new
Yeah.
platforms that are coming out.
Yeah.
That's sort of midway between just sticking with stock synthesis and completely going your own way.
Mm-hmm. And the nice thing about an ensemble is that it allows us to add or subtract models without sort of destabilizing the whole world.
Exactly.
We can add one model and we can take one model away and continue to kind of maintain the basic concept we have. So it's
FlexiBus just moved from the previous instruction model, specification model to WAM.
it's a transition.
There's a transition.
I bet. Well, I guess that's appropriate for stock that's moving north at 100 miles a year.
Yeah,
There's transitions all over that
there's enough
stuff.
transition happening in the stock assessment.
Anyhow, so that's the general prospectus for 2025. For the rest of this year, we have a few things left on the docket just to orient you to the schedule. I still, other than the maturity sensitivity and the sex ratio information, I still haven't closed any data sets this year. Everything will close over the next approximately 30 days. At the end of October, we'll finalize the data sets. These will include all the usual cast of characters. So this is all the various data sets that we track down. I'm annually greatly indebted to our data services team, who has all the contacts for everybody. I mean, other than the FIS and our fishery data, we rely on all the agencies in the US and Canada for all of this other information. So there's a huge amount of contacts and data processing and bringing the data here and getting it into our databases. And then I have a lot of processing on my end as well. But that all happens over the next 30 days. So I guess, yeah, for this paper, note the responses to your previous requests. If there's anything that comes up during this meeting that we need to think about for this year's stock assessment, it's helpful to me to be very clear between changes that would apply now and changes that would be applicable to full assessment in 2025, particularly for commissioners being clear on what we're working on. Does this apply right now, or does this apply to next year's stock assessment? So there it is. That's all what I've got.
Thank you. Any other issues related to what we've seen so far?
I want to circle back to one of the things we talked about in those simulations that you did with potential FIS bias, and that's the impact on the regions. You say you didn't get into that because you don't know the algorithm used for the regional allocations. My concern with what you've presented so far is that they're going to see 2 to 3%, and they're going to stop looking at the rest. So if there's a way, I wonder if there's a way from the existing simulation output to look at the impacts on some of the regions, which I think are going to have much more than 2 to 3%.
Yeah, so we've been discussing this, and I think Ray's probably listening in online. He may want to comment on this as well. I think we were considering going down the avenue of describing, as I mentioned earlier, describing the degree of bias we've seen within regions and areas previously, historically, and using that as the envelope to say, because it really, these FIS simulations that I've done really beg the question, well, how big could the bias be? And I think that's where it's unclear what we can do other than just look at how rapidly things have changed in the past in these areas.
I'm thinking more, less from the bias of the inputs and for what happens to stock dynamics in the fringing areas, 2A or the Western relations.
So currently the assessment isn't, it's not a spatial assessment, so I don't really have those dynamics modeled directly.
I mean, I wonder if you can do something with from the analysis you were talking about today, the inputs showing what bias you can get in areas to using those ratios, center and the fringing areas. It's kind of
Well, for the-
clunky, right? But
For the bias runs where the true trend was biased, I actually applied the same bias across all the regions,
which is not how it's going to play out.
which is not probably how it's going to play out.
Yeah, I don't have a great suggestion for how to implement this, but I think that's where the story is, right? The story is not, the 2 to 3% bias in the overall, although that as you said, that makes a difference. That's pounds of fish. But I think the real story is in management just going wild in the fringing areas. Every time you go out there every 5 years or whatever it is, having these big corrections because of contracting dynamics out there. Is there a way for the simulations to show the scale of that result that could happen out there?
Yes, we could probably come up with estimates of how far off some of the, particularly 4B, how far could 4B go in 3 years?
I think commissioners have asked about this kind of thing as well. And I was going to go over the old data to see, or see particularly for biological region, so it's increased importance. So that is something we'll bracket that change.
It's every region is kind of unique. So for example, region 2, we because of the way the stock's been distributed, we have great data for 2B and 2C for every year, and probably will. But 2A, we never sample, so we have really very little idea about 2A. But it's only 2% of the coastwide stock, and it's only less than 10% of the region 2 stock.
If you're a recreational halibut fisherman in Oregon,
It makes all the difference.
It's everything. Right?
Exactly. And so there, it's not really biological region, it's an individual reg area. In region 4, we have the trawl survey every year in the Bering Sea, and that really stabilizes the CVs and the estimates, but the fishery doesn't occur on those grounds. The fishery occurs on the edge and around the islands, which are not well sampled by the trawl survey. So although we get a robust estimate there, it may not reflect well at all the abundance that's being encountered by the fishery area. And then 4B, as Ray points out, 4B is unique because it's an area and it's a biological region on its own. And we haven't been there in 3 years now.
22, yeah. So next year will be 3 years.
Next year will be
Well,
3 years,
so we're doing well.
maybe. Yeah.
Didn't find someone to go out there.
Yeah, well, we couldn't find, and we only partially did what we wanted 3 years ago as well. It hasn't been well sampled. Sorry, I was just going to point out that in one of those, the reduced core design, there's very poor sampling in 3A and 3B as well. It's just one survey region. It's due to be stable over a number of years because that's where we did the sample. So there is huge potential for bias of a greater impact coastwide in those regions. It's not just limited to the fringes of the stock in all of its designs. I mean, we're stuck with that. And if all the action is going, it is a totally different trend, which is quite plausible in the rest of those regions that we've got big problems.
One thing we've talked about doing that maybe you actually have done it, right? Which is that we end up with a credible interval on our terminal estimates that spans negative and positive trends for an individual area. But I don't think what we may not have done is actually turn that into stock distribution estimates and actually show them, if we're at the bottom end of this range, we're going from, say, 2.5% of the, or 4.5% of the stock in 4B to 12.5% of the stock in 4B is what's implied by this amount of uncertainty.
You show those figures though, right?
We show the figures. Yeah.
Carefully reading the figures shows what those values are. Right.
Maybe some way to bracket the range of impacts by presenting what you did, which I think is great for the stock wide, but then also looking at some of these scenarios for 2A and 4B. I'm happy to keep talking about that over the next couple of days because I know that doesn't give you a lot of guidance about where to go. But I think, again, my concern is that they'll see 2 to 3% and they'll say, oh, this is not an issue.
That's our concern as well. Yeah.
I think you could almost treat it as a separate issue from the simulations. Because like, there's no way you're going to get a 15% coastwide stock decline caused by those fringe areas. Like, right. But this issue is always going to be there. If you don't sample it,
right,
it could be anything.
Yep.
Well, I'm
So
going
it's,
to put that around. It's not that. It's if you do get a 15% coastwide decline, it's happening in those areas. It could be much greater. Or,
I was thinking about the situation being that you missed the 15%. So yeah, maybe you missed it even larger.
We would have to miss some trend even in the core to get something that large. Just to give you an idea,
What we had recommended last June was to think more about separating GCEY from distribution, and I think it affects them. Right? Almost.
just to give you a sense, the 3-year average distribution, we're looking at 2.9% of the stock in 2A, 12% of the stock in 4C, D, and E, but that's covered by the Charles survey, so that doesn't drift as much. 8% of the stock in 4B, 6% of the stock in 4A, 18% in 3B, and 25% in 3A. I mean, this is the conundrum that we're in, which is that, if you're a recreational fisherman in 2A, it really matters to you. But in terms of us prioritizing a robust coastwide estimate, we're never going to choose 2A for the list of places we need to sample in a given year.
yeah,
It's too small.
absolutely. But I think that's where some of the impacts of reduced designs are going to be felt most.
Now, this issue was much more prominent prior to 2019. In 2019, they opted to give 2A a constant quota. So they've been at 1.65 million pounds for the last 5 years. That's taken a lot of the interest away, year-to-year variability. But there is some concern that if at some point they want to go back to a distribution-based approach, there could be a pretty big offset coming.
Well, even if they don't, I mean, a constant quota in an unmonitored area is a recipe for problems in the line, right?
Except that
In
2A
that
is at
unmonitored area.
Totally.
well, except that 2A is at the end of the migration pipeline.
Yeah.
So the fish tend to migrate east and south over their lifetime. So it's where they end up.
So the fishing there doesn't affect dynamics anyway. So it's
Well,
a
it
area.
probably does, but it's the end of the line. So it's not affecting anybody else's quota the same way. I mean, as much. Those fish do go back north to spawn. So we satellite tag some fish that went as far north as Southeast Alaska to spawn from 2A. So we know that they're connected across region 2, but generally these fish are moving east and south over their lifetime. So those fish are having less harvest in 2A, even if ends up having a larger effect on the local abundance is going to have less of a feedback to the whole stock than virtually any other area. The converse is like for CD&E, I think a lot of the young fish start there. So a higher exploitation rate there is potentially going to affect yields, pretty high feedback to yields everywhere. 4B is its own creature. We have, honestly, wouldn't have been surprised if Andy had found strong stock structure in 4B. It seems to function differently, but yet also seems to be part of the same genetic pool. Dynamics seem to be quite different there.
So the information's weaker, noisier.
It is, and the sampling of the fishery doesn't fish most of the area. Even the survey, when we go out there, it's difficult. It's a difficult place to sample. I think maybe we should put this one on the notebook, and after we work through Alan and Ray's talks, revisit this. I definitely think that some way to highlight that the impacts are not just coastwide of these designs is critically important. So any ideas we come up with would be really helpful.
Sounds good. Yeah, we have some time after lunch. Continue some other on or off mic discussions. Okay. So I think we can move on to the agenda item, which is the MSE work.
Yep, that's correct. Okay. All right. Thank you. And good to see everybody. Gonna have a nice day today and not so nice day tomorrow in the weather-wise. So you'll get all of Seattle's weather in 2 days. So enjoy it today while you can. But I don't mind if you stare out the window a little bit. So I'll talk about a number of things with the MSE work done since June, and we've actually been very busy and a lot of different topics to go over today. I'm going to start talking about the Harvest Strategy Policy document, which is an info document on the SRB025 website. And we're looking to bring that to commissioners soon. So I'll give you a timeline on that in this presentation. Talk about goals and objectives. There's a couple SRB requests related to those, and that MSAB had a ad hoc working group meeting this summer where we started that discussion with the MSAB members. We did a lot of investigation of various management procedures. The FIS designs obviously is going to be an interesting conversation, and then some work on compensation stress tests. So a number of topics, and I'll pause at the end of each one of these topics with a little summary slide so you'll know when that's the end of the topic. Okay, the Harvest Strategy Policy. The SRB a year ago now recommended the commission consider revising this and basically removing the distribution component of this as a component of the specific management procedure to make this process a little bit easier. And so we've rewritten the draft Harvest Strategy Policy document to reflect this, and the commission is certainly on board with some removing distribution from the management procedure part of it, realizing that it's an important part of the process yet. And what we've done is modified the illustration of what a Harvest Strategy Policy for IPHC looks like into having basically this coast-wide scale aspect on the left, and then a decision-making component or the annual meeting on the right, where the coast-wide TCY is basically the output from the coast-wide scale component or the management procedure that then feeds into the process of the annual meeting where the commission makes their decisions, and they receive a lot of what we call management supporting information. The commission receives that information, subsidiary bodies receive that information, and then the commission makes this decision, which are actual TCY at the regulatory areas. So we've embraced this concept and really treating distribution as part of the distribution or the decision-making process. And in this draft Harvest Strategy Policy, which includes that illustration, that figure, we have it separated into 4 different chapters: an introduction, objectives and key principles, development of the harvest strategy policy, sort of the standards for developing it, and then applying it. What does the actual application of this harvest strategy policy look like? And there's a few sections that we're still completing, such as the definition of overfishing, the monitoring section, the stock assessment section, we're working on. And then if there are any suggested changes to the current interim management procedure, which is this SPR based reference 43% SPR, if there's the MSC work is in support of that and the commission wants to change that, we'll obviously modify that in this document. So I want to go over a couple of things that I think the SRB would be interested in. And one is the definitions of overfished and overfishing, where overfished is pretty simple definition, just maintaining the biomass above that limit spawning biomass reference point of 20%, and making sure that that is greater than 50%. If it's not a greater than 50% probability, it's overfished. We've defined it as overfished. Overfishing is the one that we've been putting a little bit of thought into. And the definition we have right now is where the stock is subject to a level of fishing that would move it to an overfished state or prevent it from rebuilding to a not overfished state within a specific time frame and probability, both of those yet to be determined.
I think we had quite a debate about this last time.
Okay.
About having definitions of overfish and overfishing that are completely different from fisheries theory. Overfished is the stock below BMSY, which is presumably nowhere near 20%.
That's what.
Yeah.
Otherwise, it'd be overfished.
Yeah.
Or do you be in the swat, you'd be overfished.
Half of the time.
Theoretically, I mean, it's, yeah, the theoretical definition is that, yeah, you're overfishing if your stock is below BMSY. That's been the, in the US, but this is a US Canadian fisheries department.
The Canadian Fisheries Act, I guess you call it, in Canada, though, also has a percentage of BMSY.
It's a limit
The
reference
limit,
point
reference
to not go below.
Yeah.
That's, which is different. It's not declared overfished or not in that case. I mean, Ray Hilborn came up with sustainable overfishing as a thing.
Yeah.
Which is technically, yeah, when you're below BMSY, you're sustainably overfishing.
Well, the two definitions, the two definitions here are really hinged on overfished is basically a state of the population we do not want to go to. And maybe overfished is not the right word for that. We use that in the MSC objectives, the 20%, and a place we want to avoid. If we get there, we want to quickly climb out of there and recover the stock. And overfishing, we've been really thinking about how overfishing relates to overfished. And so we're really trying to connect these two concepts with each other. And instead of overfishing be a concept that's based on a fishing rate, where say your fishing rate to achieve BMSY is 42%, whatever that means. And if you're fishing at a rate greater than 42%, you're overfishing. But if you're the first year you've ever fished this stock, you can still overfish. You can fish above that rate and drive the stock down to the levels that you want it at. So we wanted to avoid that situation where you might want to fish at a harder level because the stock is a really high size and bring it down to those MSY or whatever target levels might be. And so we really wanted to bring that concept of overfishing is like, where's the stock heading? And is there a high probability that it could be overfished in the future? And that's what we're working on with the overfishing definition. I take your point in the definition of overfished. That's a limit reference point, something that you really want to avoid. And maybe there's a better reference point to be using there. And more aligned with the classic fisheries theory related to MSY type concepts.
So, I mean, it's also, you know, this is a particular definition. Like, you know, overfish and overfishing, they have, you know, they're derived from fisheries theory, which is a deterministic theory.
Yeah.
Whereas this starts right off with the estimated probability. So this is very idiosyncratic to the model you're using, the data you have, very specific. You know, where a term overfish and overfishing have, like, for 100 years have had a certain definition that's been in the textbooks and everything.
Mm-hmm.
That's my concern about it. It's just confusing the poor people
Okay.
who were taught something that, you know, now the language is changing. I don't know if there's, I mean, I'm totally fine with the purpose of it all,
Yeah.
but yeah, I don't know if you can change the terminology.
Okay. Yeah. We'll certainly think about that. I take your point, and it, you know, my 20 years in fishery science, I was definitely confused about what overfished and overfishing meant, especially when
The
I
whole
jumped
Colby
between.
plot was created for, and
Yeah.
you know, all that stuff is based on that concept.
Yeah.
But what would you call it otherwise?
I don't
I've
know.
never heard it called something. Like in Canada, for example, they would call it critical. The state of the stock would be critical instead of overfished, which gives a little bit more gravitas to this being below 20%.
And
Zero.
yeah, another something else that we are constantly thinking about when writing this harvest strategy policy is how this would be interpreted by the different certification agencies, for example, and how they measure their certification against our management performance. And so they would be looking, probably, I imagine many of them would be looking for a definition of overfished or overfishing, or they might have their own. Sure.
It's a good question. I see what something like MSC would do in that case.
I can't remember their definition.
I mean, I don't think if you, they don't seem too discernible when F is greater than FMSY, as long as there's a plan in place and all that other stuff. Right? So they're not very strict on trying to define something as overfished or not.
It's kind of hard to think about these terms divorced from the management action that they apply.
Mm-hmm.
You know, in the US, overfished has a specific management action, right? So it's declared overfished. Half will be FSY. Then it goes into a rebuilding plan.
Yep.
It's a totally different management framework.
Yep.
Harvest control that applies otherwise.
Yep.
So that definition has, you know, critical importance because it completely changes the management. Here, I don't think these are tied to specific management actions. Right.
In the harvest strategy policy, we've written that when a stock is declared overfished, that it's reasonable action is taken to rebuild that stock above the overfished level as quickly as possible. And that's where, you know, we do still need, we want to define these stock timeframes and probabilities. Right now, we've written that the stock would be declared not overfished once you have a greater than 70% probability that it's above the overfished level. So we haven't tied specific management action into these definitions, but we certainly would expect management action to occur if these conditions were met. And that's sort of still what's in progress in developing this harvest strategy policy. Our real goal at this time is to have this document, a draft of this document endorsed by the commissioners. Not complete, we're still working on it, but it's just really time for us to have a harvest strategy policy at IPHC.
Wouldn't a term instead of overfished, a more accurate term would be depleted. That would be more consistent with, if you look at some of the global assessments of fish stocks, like there's ones that are depleted would fall within that first category. Versus overfished,
Right.
a lot of them,
Right.
a lot of them fall in overfished, but depleted is different. And that implies, yeah, you should be doing something about that.
Yeah. Yeah.
Overfishing.
So, well, I guess in general concepts, is the SRB in agreement that overfishing could be defined as the potential to become depleted or overfished?
Well, if you're fishing at greater than FMSY, then at some point, yes, that will. Well, it doesn't necessarily imply that you will become depleted. It implies you'll go below BMSY, but if you go 1 ton below BMSY, you're overfished
Not in
and
this
you're
case, right.
overfishing.
Right, we want to be careful of
You're
that.
not depleted, and you're not really headed for it.
So yeah, the overfishing definition would be more related to the depleted or overfished.
I think
Right.
that's what you're trying to get at.
Yeah.
There's something that
I think this is pretty analogous to the US system,
Yeah.
which is why it makes sense to me. It's the one that I'm very familiar with. So I don't have a problem with it. The overfishing one is different though. It's about within a specific time frame, whereas in the US
Right.
federal system, it's illegal to set the quota that will result in overfishing greater than
Right.
50% probability
Exactly.
in any 1 year.
Yep, exactly. And we're trying to avoid that because there are times when you might want to fish down a stock.
Right. I mean, there are
Yeah.
economic strategies
Yeah.
that involve F greater than FMSY
Mhm.
temporarily.
For a short period of time, right? Well, I'll move on from this, and I'm certainly happy to have more discussion about this. But I think this is something we wanted to bring to your attention, and I appreciate these. We've been researching many different harvest strategies around the world: New Zealand, Australia, Canada, and the U.S. are the ones I'm most familiar with, and so a lot of these are based on sort of those concepts as well.
Yeah, Alan, sorry to interrupt. Noting that this afternoon we do have some offline discussion
yeah.
time. It would be great if the SRB and ourselves could really try and just work through it a little bit more to see if we can try and consensus on a path forward.
Yeah,
Commission review.
that'd be a great use of that time.
Just one more, maybe
Yep.
placeholder for later discussion is that the switching to a different management framework once you go below that threshold. That rebuilding framework that you move to as opposed to a harvest control rule. That has value. I think that doesn't always get captured within MSCs
Yeah.
because the value of that is if you're wrong about stock dynamics, it provides an escape valve where you leave the management procedure and go to an alternative, which is focused on rebuilding. So, and you wouldn't need that if everything is performing correctly, right?
Right,
So,
right.
So often, I think that has importance that doesn't come out with an MSC. So I just a placeholder to maybe talk about that.
Yeah, that's really good. Thanks a lot. All right, I'll move on then from this slide. And another part of the harvest strategy policy are when we would want to reevaluate the management procedure or the MSE work done that's developed this harvest strategy policy. And based on the SRB request from the last meeting, we've now inserted just one single exceptional circumstances based on the coastwide all sizes FIS WPUE at this point in time. So that's reflected from a previous request. And I want to bring it to the attention of the SRB that the MSAB had some requests related to exceptional circumstances. This is from the MSAB meeting last May. And really that the MSAB has requested the SRB and the Secretariat work together to consider different ways to incorporate fishery-dependent data into an exceptional circumstance. We had a little bit of discussion about this at the last SRB meeting. And I just want to bring up again, a part of that discussion was making sure if fishery-dependent data were to be used as an exceptional circumstance to delineate between changes in that data that would be reflective of something not working in the MSE versus changes in the data that are caused by management issues, such as avoidance of other species or things like that. So if it's based on a CPUE, it might not be an issue with the management. It might be more of a change in the process. So we'll try to explain that to the MSAB at the October meeting. But this was a request from them. I just want to make sure the SRB is aware of that if we want to have further discussion on this. So in summary of the draft harvest strategy policy, the timeline for this is we're providing an updated draft to the MSAB, MSAB 20, which is occurring at the end of October. And it was actually a directive from the commission at work meeting that we had earlier this month to update the draft, the harvest strategy policy, pass it to the MSAB. They can make some recommendations in October. If necessary, we'll modify that. We'll provide a draft to the commission at the interim meeting for them to take up and discuss. And then the commission will consider for endorsement at the 101st annual meeting this coming January. So the current draft available as an info document on the SRB website is currently being updated to reflect some of the commission directives. And that draft is going to be available, I think September 29th was our due date somewhere. So we're hoping to have that done by August Friday. So if that's okay, I'll move on to the next topic here. Goals and objectives, and a couple of recommendations from the SRB related to goals and objectives are this objective C, optimize yield. The SRB says that's pretty ambiguous, more specific and quantifiable definition would be helpful. So we're working on that. And then the second request or recommendation from the SRB is to consider this target objective and refining that. What some people call a target objective, we call a threshold D36%, because it's not actually a target, but just remaining above it. But finding a better way to capture the intent of the commission and their recent decision making, at least related to that. So the MSAB had an ad hoc working group meeting in July, and the focus was to explore potential new objectives to replace B and C, both of these recommendations from the SRB. So I want to walk through the specifics of these. So first, talking about optimizing average coastwide TCEY. We'll definitely be having more discussion at MSAB 20, but out of this ad hoc meeting, one thing that came out of there is that the objective optimized yield may include reducing interannual variability in yield. So the MSAB is realizing that optimizing yield is much bigger than what they were hoping as an objective. And we're trying to define that. And so thinking about it a little bit more, we realized here, the staff, that optimizing yield to the stakeholders may also include maximizing or having the ability to have high yields when biomass is available to them. And so this is something the MSAB has talked about when, say, weighted age is increasing and good and big recruitment, they still want the opportunity to have those high yields. So we're going to flesh out with them the meaning of what optimized yield means to them.
Sorry. Is there a reason why using maximize yield, like subject to other things?
We originally had an objective to maximize the yield, and then they did realize that the interannual variability in yield was very important to them as well. And so it was always like, well, we're maximizing yield, but now we don't want to maximize yield because we want to reduce interannual variability. And that's why we moved to this concept of optimizing yield. But we never moved further to really identify what optimizing yield means and how to evaluate that trade-off between the interannual variability and yield and the maximizing the yield. So that's something we'll work with on the MSAP. I think we did have a discussion at the last SRB meeting about, I think it was mentioned by you maximizing yield subject to some other.
Constraint optimization.
Yeah.
is a definable objective.
Yeah, yeah.
Optimizing is not.
Right.
They want to see like trade-off plots, yield variability trade-off plots. Those are pretty straightforward to produce.
They are, and we've tried that in the past, and don't know why they haven't
like-
worked. Yeah, and I think with the MSAB, it's a great group of stakeholders to work with, and they've been learning quite rapidly, through this process, and things come out. But I think there's some different objectives or priority objectives among the different members, and some do want to maximize yield, some want to reduce interannual variability, some want to think about their area. So we're really trying to figure out the best way to present these, but we have presented the trade-off plots in the past, and so I think we could work on just, if we have better defined objectives, then I think those trade-off plots might be a little bit more.
Is this a situation where people from all over the place have to agree on a single objective? Or are you considering everybody, let's say each regulatory area can have its own objective, and then you're going to some weighted weighting those in a combined one? There's other ways of doing this, right?
Yeah.
Getting groups to come to a consensus on something.
So when distribution was sort of on the table and we were really thinking about the TCY in each regulatory area, we did think about it that way. And we had different objectives by each regulatory area. This new paradigm of not focusing on distribution makes it a little bit more difficult to focus on regulatory area specific objectives. So we've really stuck to these coastwide objectives, and that's the commission really wants 4 primary coastwide objectives. And that's what they want to base these decisions on. And so bringing it together in that sense, we haven't figured out a way to do that, to bring their specific interests into a coastwide concept. And so we've been trying to think of it as just these trade-offs at the coastwide level between what the yield is and what the interannual variability in yield is. The second objective in the request of the SRB is to maintain this relative spawning biomass at or above 36%. And just put a couple of statistics that have come out of the MSE work is if you were to consistently fish at an SPR 43%, the long-term median relative spawning biomass would be 38.8%. So that would be above. And 43% SPR is our current reference interim SPR level. When fishing at an SPR 40%, the long-term relative spawning biomass would be 36.6. So it's really about an SPR of 39% would put you right at this level on the median from the MSE results. The recent decisions have equated to an SPR greater than 50% to give you an idea where the commission is at and why this isn't really a target per se, but more as a threshold that you want to keep the biomass above. And a reminder that the relative spawning biomass is a dynamic measure of relative spawning biomass as well. So at this ad hoc meeting of the MSAB, a couple of points: the management procedure defined as a reference fishing intensity or more conservative would provide the flexibility of the commission to decide on a fishing intensity less than some maximum fishing intensity. So like a limit fishing intensity or something like that. And then evaluating MPs based on performance of the worst conditions may result in avoiding low stock sizes under any condition. So they're thinking about what are worst case scenarios, least productive times of the stock, and looking at how the MPs perform in those types of periods. So
Those are worst conditions defined on productivity or defined on data availability and information flow.
Yeah, low productivity, no data, big.
Yeah,
trend, and-
Yeah, other things are okay with themselves, you can deal with it.
right. And I think the MSAB is really, when they phrased this, was thinking about productivity more, because we were talking about low and high regimes and what the difference is. And I've done some simulations with those specifically. But they're going to get a big taste of data availability at this upcoming meeting. So related to this is the next slide, and that's just redefining this objective altogether and redefining it as a new objective where related to some absolute biomass level, say not having a low probability of the absolute spawning biomass going below what was estimated in 2023, for example, something like that. So this is an objective we've been working on with the MSAP for a while. I've mentioned it to the SRB also. And a couple of things came out of the ad hoc meeting on this, which we'll take to MSAP 20. It could be defined on a number of different things, but I think at the end of this ad hoc meeting, everybody was sort of realizing estimated spawning biomass was probably better than fishery dependent data, CPUE or something. Just the things that can affect CPUE is so broad. We could specifically try to meet this objective or any of these objectives by adding elements to the management procedure, like a control rule that shuts off fishing or whatever. And this last one's really interesting. There's likely a desire to remain above the absolute spawning biomass in 2023, and the tolerance could be 80 or 90%. Man, when we got that written down, I was like, well, there's success right there. That's a huge success.
So they really don't like it where it is now.
Yeah.
They want to have an 80% chance of being above.
Yeah.
Smart.
And so when we wrote that down, Ian and I looked at each other and I said, this is the
That's
formation
nice.
of an objective.
That's nice and specific.
Yeah.
Right?
Yeah. So we want to bring this to the MSAB and then to the commission, of course, to see if it would be, the commission is not interested in adding a new objective to this list of 4 they currently have. So we're really looking to replace that B36% objective with something more meaningful. And it looks like we might be on it.
That's good.
Yeah.
Once you get out into those, 80, 90% probabilities, small differences make a big difference. Right? If you want to have a 90% chance, that implies a really good policy than 80%.
Yeah.
Expect because you're way out there in the tails.
Yeah. And requires a lot of simulations to get the tail probabilities. So I think the ad hoc meeting of the MSAB was a very useful meeting. It was a pretty intense 1-day meeting online. And we got some good things to bring us into the MSAB meeting coming up and hopefully make some progress. So in summary, as I just said, that was a successful meeting and we'll continue these discussions at MSAB 20.
It'd be interesting with that 90%, if they chose 90%, because that's going to be sensitive to data, to the data implications, but also it's not as robustly done unless you're running way more simulations, which is it's just time.
Yeah. The other
versus something like I'm picking a higher biomass on median, which would be stable and probably won't show much at all response to data,
right,
except over a really long time.
Once you get down into those kinds of probabilities, there's just stochastic effects, right? That make that, even in the absence of fishing, you might not be able to achieve that objective. So,
Yeah.
do you know,
Yeah,
Jim Forson's 2014 paper, a stochastic risk of overfishing, or just simulates different life histories.
Oh, yeah, I haven't, yeah, that's been a long time. Yeah.
There's like a 5% chance of being overfished for a lot of different life history combinations in the absence of fishing.
Yep. And we used to do that for Pacific hake all the time. That was higher than 5%. So,
So things like that, might not be achieved. Might not be a magic procedure that gets you
Yep.
there, given the dynamics of the stock and the variability.
and to be honest, given the variability in these regimes, I think fishing at a F43%, what was it, a 1 in 4 chance of going below the spawning biomass in 2023? So it would, to meet that objective, 80-90% would be reducing the fishing intensity quite a bit. And if you get stuck in one of these low productivity regimes, it's a pretty high probability of going to those low levels. And that's something we've been explaining to the MSAB and the commissioners, is that where we're at today is a combination of factors of fishing and of just the productivity of the stock and what it's experienced over the last couple of decades. And how often should we expect to be down here is part of the outcomes of this MSC that I think are informative to them as well.
A no fish, suggested a no fishing scenario is a useful baseline to say like, we just can't get it.
Yeah.
We can't achieve that. Or, we'll only have a 70% chance of achieving that, even if we
Yeah.
no fishing.
That almost suggests using the relative spawning biomass in 2023 rather than the absolute.
Except that it's the absolute biomass that affects the catch rates, right?
Yeah, but if you're down into a low, what regime are we in now? 2023? Is that a
So
result?
it's been flip-flopping a little more often than normal in the last decade or so.
We're in a low regime,
So you're-
regardless of where the PDO sits.
So you're basically saying, well, we're not going to fish. Which sounds unlikely.
And the MSAB has responded really well to those types of lessons from the MSC simulations in the past. When I first came in, they said, we want to get back to catch level to 70 million pounds. Did a bunch of simulations. And I said, can't do it. Sorry.
So
You know, and they all said, wow, okay, that's good to know. And started readjusting their objectives.
Yeah, I mean, I've struggled with this one too, because we have it for some of our species where, what do you do when you're in a low productivity regime? You got this dynamic B0 that says, yeah, you can fish all you want down here, but is it really realistic? And how would you measure the impact of that? Because it's like when the regime flips back to normal, maybe you can measure how what the recovery rate is, or there's got to be some implication of continuing to fish at some target when you put a dynamic B0
Right.
and the stock is low, regardless of what you do. It's a tough. No. I mean, herring fisheries are closed in BC right now. They've been closed for almost 20 years in some cases.
And
It
that's,
also takes time to notice that the regime has changed.
Yeah.
Those can be critical years.
Mhm. Yeah, but that's the conundrum we're in is, in a dynamic relative spawning biomass sense, status looks good. The SPR is suggesting catches wherever they are, but the stakeholders are not happy with their catch rates.
There's no magic procedure to change that.
Right. Yeah.
I think you're gonna get to this, but that's also where, understanding dynamics of low stock size and compensation becomes really critical. So it's up to that productivity regime. It doesn't matter, you're far from these thresholds. We're
Right.
talking about how much to fish in a low productivity regime, even though you're intelligent, you're still down at here there be dragons area.
Yeah.
The crude curve, right?
Yeah. We will discuss that. Yeah. All right. I'll move on to the next topic here. And this is the various management procedures. So this is, the really fun part for me. And that's the evaluation, doing the simulations and the evaluation. So we've looked at a number of things this year. Assessment frequency being annual, biennial, and then an empirical management procedure, which all I'm going to present here is when there's not an assessment, the change in the TCY is proportional to the change in the FIS 032 WPE. So for a little foreshadowing, that also means that in that biennial and triennial with the empirical rule that the CV on the FIS is important. And that's when we get to the FIS designs that'll have an effect in those types of decisions. We looked at a constraint of just constraining the change in the TCY 15% up or down. So it can't go up more than 15%, but it can't go down more than 15%. A more recent simulation that I finished after this presentation is it can't go up more than 15%, but it can go down. It should go down the entire amount. So that's like a fast, full down, slow up. Various fishing intensities, and then the FIS designs, which I'll cover as a separate topic after these. Now, just want to remind everybody that distribution of the TCY is part of the decision-making process. We had discussion last SRB about this, and distribution is really treated in the MSE simulations as an uncertainty. So there was a request here, paragraph 24 from the SRB meeting last time on what the SRB recommended approach to simulating this was. And so we've implemented that into the management procedures of the MSE simulations, where the TCY in 2A is fixed at 1.65. The TCY in 2B is a random draw from a triangle distribution between 17 and 21% with its mode at what the average has been in the last 13 years, I think. And then the TCY in the Alaskan areas was basically, we have the percentage distributed to each Alaskan area, minus 2A and 2B, for each of the years 2013 to 24. And we just randomly sample one of those years. And that's the percentages that go to each of those regulatory areas. So that's the process for distributing the TCY to the regulatory areas. And then we will actually look at the management procedures, these other management procedures, and evaluate those. And so here they all are in a table with the constraints, the assessment. Depensation is in here, and empirical rule is in here as well, which we'll talk about depensation on the far right as the last topic of the day. But we have the different SPR rates going down these different rows. We have annual, biennial, triennial. No constraint. We added the one single constraint for an SPR 43%. And then we did 3 fishing intensities for the depensation level of 2.
Sorry, what do the NAs mean?
The empirical rule is just not applicable because it's an annual assessment. Yeah. So we didn't do any biennial, triennial assessments with a constraint or in the depensation. There is a MSE Explorer where you can look at all sorts of different objectives, and there's actually more combinations than just these. This is what I'm going to present today, and that's at this website, which is you could just link to it right here. Look at that. We can bring up anything if you have something particular you want to see. So let's first talk about performance metrics for the different assessment frequencies and SPR values. So this is really the core of the MSE simulations. We have at the very top an annual assessment frequency, in the middle a biennial assessment frequency, and at the bottom a triennial assessment frequency. And the 4 priority objectives or performance metrics related to the 4 primary objectives of the commission, being the probability of maintaining the relative spawning biomass above 20%, or sorry, probability that it's less than 20%, that is less than 36%, then the median TCY and the AAV, or the average annual variability. I want to note first the bottom section here, the triennial was accidentally simulated without decision-making variability on it. So these results are a bit more optimistic. I've fixed that and I have new results with decision-making variability, which all of these include decision-making variability, or at least the annual and biennial. And we'll talk about that in a moment. So basically, when you look across these, you can see, let's first focus on the 43% going down. And you see with the annual and the biennial and the triennial assessments, as you go from annual to biennial to triennial, the median TCY actually increases slightly. And the AAV decreases slightly. Noting here, the AAV still decreases for the triennial with decision-making variability. It just doesn't go down to 17.2%, it's about 20%. So that's a pretty interesting result, is that the TCY increases and the variability decreases. That's really good. You don't see that happen.
Why is it more than 15%?
All of these, there's no constraint on any of these.
Oh, this doesn't have the 15%
No.
up or down constraint.
No, and so, but you might notice too, they're larger percentages than we have seen in simulations in the past. And one reason is when we talk about the FIST designs, we've now moved to a slightly more uncertain assessment and uncertain FIST estimates. And we've implemented decision-making variability in here as well, which is having a big effect on these results. I'll show you some simulations without decision-making variability. But there's more uncertainty in general in these simulations than we have shown in the past simulations. And that's because of the reduced FIST designs and the decision-making variability. So that's interesting. Another interesting result is when you look at the AAV across the different SPR values, it's not monotonic. It actually decreases and it's at a low point and then it begins to increase again. Yeah, for all of these runs.
Can you highlight that?
Yeah, sorry. Yeah, I'm not showing the very good pointer here. So when you look at the AAV across this row, you see it goes 25.3, 24.2, 23, and then it begins to increase again. The triennial doesn't, as you remember, these numbers are without decision-making variability. With decision-making variability, it does increase. So there's some, I can't explain it. There's some weird thing happening with decision-making variability here that's causing it to have this U shape in the AAV.
But when you see that it's stock, it's larger, you've got larger, the errors are proportionally larger in the fits,
So
which doesn't, what's the
Yeah.
AUV picking up?
yep, yeah, that could be. The way that decision-making variability is simulated, and we can have a more discussion about this. We discussed this a lot internally, how to do this, and I presented some stuff at the last SRB meeting, and it's in this document again, about how the commission decisions have occurred in the last 10 years or so. And what we found is that for many years, the commission tended to stay towards status quo. Not necessarily the advice of the assessment. They were deviating quite far from the assessment, but they were sticking close to status quo. And then in 2 recent years, they departed quite far from the advice of the assessment, where the assessment was saying, 50 million pounds, and they chose 35, approximately. And so that there isn't really we couldn't find real pattern to their decisions. And so we just decided to have a random normal distribution around the assessment advice. And that normal distribution had a fixed standard deviation of 7 million pounds. So regardless of where you were, if it was 20 million pounds, same standard deviation as 80 million pounds. And we figured that that's just one way that we decided to implement it at this time. And you'll see that the results are sensitive to the decision-making variability that way it's simulated. The weird pattern in the AAV, we also see that you can also see that we're getting close to a probability of 0.5 for being less than the 36%, which is what I mentioned earlier. The TCY is reduced about 4 million pounds with an increase, SPR increase of 3%, which I think matches what Ian was saying earlier. We're about a 1 to 1.5 million pound per percentage of SPR. And the AAV is high in general across all of these. The MSAB has stated they would really like very interannual change to be less than 15%, which is why we have these constraints of 15%. And now we're showing that's quite larger than that. So I want to show you the effect of the constraint on these results. And so what we're showing here is with an SPR of only 43%, we have no decision-making variability on the left here. And then on the right, we have decision-making variability. So we're showing a couple of things on this slide, the effect of a constraint and the effect of decision-making variability. So let's focus on this column, none, and this column, none, and look at just the effect of decision-making variability. And you see it reduces the AAV, but that AAV is still quite high at around 20.8% without the decision-making variability. And again, this is new simulations incorporating the reduced FIST designs, and we'll see how that was done and what the consequences of those are in the next topic.
Can I just clarify?
Yep.
Decision-making variability here is apportionment to the regions, or is it deviating?
At the coastwide level. So it's setting a, so we still have that uncertainty in the distribution to the different regulatory areas. But this decision-making variability is how much they're going to depart at the coastwide level from the assessment advice. And this is all annual, so it's the assessment advice. Now, 7 million pound standard deviation around that. When we simulated the biennial and triennial assessments, and that TCY was determined from the empirical rule, we still simulated decision-making variability on top of that. So the FIS changed to set this the TCY, and then the commissions could make a decision to change it from there. The other thing you'll see is that yield is pretty similar without the constraint across with and without decision-making variability. Slightly greater with decision-making variability, but that's a very small amount, especially when you look at the range of yields that were simulated. The interesting stuff comes in when you introduce the constraint. And so putting a 15% constraint on the change in the TCY without decision-making variability maintains that below 15% now, which you would expect. And if you actually, these are short term, in the short term, the TCY and the AAV, if you look at the long-term results, it's more close to exactly 15%.
When you look at decision-making variability, I think this one probably reflects decision-making because you said it tends to be more stable. They tend to stabilize, go with status quo.
They had for a number of years, and then that changed. That was the conversation we had. It's like, do they tend to stabilize it? Like, yeah. And so we used to simulate decision-making variability.
More like the 15% constraint.
Yeah. It used to be more like that, but then in recent years there was, these concerns, and they really started departing from assessment advice and going away from the status quo more so. There's a figure in the document I didn't reproduce here, but we can bring that up if you want to see it.
It sounds like that's because they had this other unstated objective, which was to avoid going to
Yep.
those things.
Yep.
Which is now stated.
Yeah, and it was confounded also with the change in M in one of the models in the ensemble, which increased the assessment by a slightly higher TCY potentially. So all of a sudden we went from the assessment model was suggesting about 40 million pounds, and then with the change in M, it was up to the high 40s. And so now the departure is even greater. The commission is departing even a greater amount. So I think I'm happy to discuss decision-making variability, but we came to the conclusion, it's like, we don't know what they're going to do in the future. We just have to simulate something.
It's an uncertainty case, right? Where you've got a recent departure from the long-term rule. You go to the long-term rule and assume that the recent stuff is an aberration, or you assume that the
Right.
recent stuff is the new normal.
Yeah.
Or you could ask them like, okay, so you're gonna continue doing what you're doing, but can you at least keep it within 15%?
And that's something I think the stakeholders would like to ask them, to do, but I'm not sure the commission, they like to maintain their flexibility. Sure.
15% a lot.
Yeah. So then when you have the constraint with decision-making variability, the decision-making variability is on top of that constraint, but you see that it still does reduce the variability, interannual variability in the yield by quite a bit. But what's really interesting is how much the constraint is affecting yield. So it really reduces the yield. The spawning biomass is higher because it has a really small probability of being below 36%. And with decision-making variability, that's even reduced even more. So that constraint is actually keeping fish in the water.
It's probably keeping them from making big dramatic increases.
Yeah, so results I'm not showing in this slide, but I just wrote up in the MSAB document are the constraint only on the way up, only on the increases, constraint at only 15% when it's an increase, and taking the full down. And the results were actually pretty similar to the constraint both ways. So I think you're exactly right. It's more constraining on the increases rather than the decreases.
I think that demonstrates the point that came up in Ian's presentation, is that giving up a little bit of catch and taking a little too much, it's an asymmetric cost. And this shows the long-term.
Yeah. Okay, so that's the constraint. And that's really the core of the management procedures. We've really been focusing on the assessment frequency, the empirical rule, the different fishing intensities, and the constraint, a potential constraint. And I think the MSAB is going to find these results with this constraint very interesting. I'm curious to see what they think of it. So in summary, there's really no conservation concerns, and that's really an effect of the control rule, this 30-20 control rule. Just once you start fishing below like an SPR of 38%, it's really limiting, and the realized SPR really sort of just asymptotes at about 36-35%. You never really get below that. An SPR around 39% would result in a median RSB about 36% for that threshold objective. Matching what Ian said earlier, an increase of 1% in the SPR is about a 1.3 million pound decrease in the TCY, or an increase in, right, that's right. Always have to think about that one. The triennial assessment frequency resulted in increased TCY and reduced AAV even when simulating it correctly. Just not as large of an effect as I showed in this slide. 15% constraint reduced the TCY and the AAV, and then decision-making variability is an important component, and as I've mentioned, very difficult to determine how to model.
I think that triennial assessment frequency result is just super powerful. Right? There's just very little trade-off in
assessments.
And you mean by very little?
You don't lose much, right?
Yeah.
And you gain, I mean, the gains there are pretty clear.
Yeah. So what I've been doing for the MSAB is we've created some more performance metrics to try to get at what is happening in every single year. So you go to a triennial assessment, and the classic, the easiest way to think about it is say you have an empirical rule that just keeps a static TCY in non-assessment years. So you have no variability for 3 years, and then you have a big jump. And so the average annual variability might be less, but where stakeholders be okay with the big jump that occurs, the correction that occurs to get you back on track. And so we've developed some performance metrics, like one was just looking over a 15-year period instead of a 10-year period, calculating the AAP. That didn't make much difference. We calculate what's the maximum change, I think, or what's the maximum absolute change in the TCY over a 10-year period. And that's actually pretty interesting. It showed that going to triennial, the maximum change actually increased. So it is making this correction every once in a while, but it didn't increase a whole lot. I think the maximum change maybe 500,000 to £1 million. I literally just wrote this up last night.
Well, I mean, that's just the life history.
Yeah, exactly. Yeah. And then the last one, I forget what the last performance metric was, but I can show you these things. That'll be published this Friday in the MSAB document, so it's hot off the press, but I'm happy to show you these things this afternoon if you want to see those more closely. But I agree with you, going to a triennial assessment, there's a lot of benefits. Here, seeing there's some benefits, but as Ian said also, there's a lot of benefits on the stock assessment development. That's something.
I think that's something we've all recognized. That this is great because it says that all those benefits of freeing up Ian's time come at no cost, and even some benefit in terms of fishery performance.
It would be really interesting.
Why not?
Yeah, it'd be interesting to write that up in the report. What the commission does is asked us in the past related to these biennial and triennial assessments is what are the costs? And that's something where we've been trying to identify, lack of that tactical assessment every year. Is that something that stakeholders and commissioners really want to see? And so we've been trying to identify some of the costs, and I'll probably have to bring those up with the commissioners again.
So just clarify that in triennial, the survey is done triennially? Or
The survey's done every year.
always. So every time an assessment is done, it's got
3 extra years of survey data. But the survey is also used as the empirical rule. So we need to have that survey every year. The other thing is that having an empirical rule based on the survey requires a survey, right? And that puts a little bit more emphasis potentially on the survey and having a good design of the survey as well.
I was thinking maybe if you had triennial survey, then you could do the full survey, all stations every third year.
And I have no idea how that works with the budgeting, but I think part of it is too, we have a survey team in-house, making sure that's budget, annual budget aspect, and, things like that as well.
Have your survey team.
Yeah, I mean, it would be a lot of learning every 3 years, wouldn't it?
And that need for an empirical rule is really, at least transiently right now, a huge impediment to talking about a 3-year assessment, because we're now at a point where we don't have solid survey. And so everybody's concern is, well, if we went to a 3-year assessment, what would we use as the empirical rule? A survey that looks like 2024. So it's a real sticking point right now.
Yeah, and it gets at Ian's point there. Like, the survey is very important to stakeholders to see, the results. Everybody's looking forward to the results of the survey. They want to know, and then they want to compare it to their catch rates, and stuff. So I think on an annual basis, it's just a really important product of IPHC. Speaking of the survey, that's the next topic, the FIST design. So would you like to move on to that one? Okay, so I've identified actually 4 FIST designs. And Ian mentioned earlier the 3 base block core and reduced core. I've thrown in the base here, although I didn't. I did a couple simulations with it, but I'm not reporting any simulations with the base. And that's really the ideal sampling approach. And I mention it here because that's what past MSC simulations were really based on, was this ideal sampling approach. Not only what the CVs on the FIST were, but how the assessment was affected by those CVs. And you saw Ian said, there's a increase in uncertainty with the reduced designs and the assessment. So we tried to bring that into here. So again, the base block is just sampling in all IPHC regulatory areas with this rotation every 1 to 5 years. The core is sampling 2B, 2C, 3A, and 3B, other areas not surveyed. And then the reduced core is even a smaller subset of that. So in parameterizing the MSC simulations, we've used the space-time model outputs that Ray's produced, as well as assessment simulations that Ian's presented earlier today to parameterize those. And that's what I'll present first, exactly how these different designs were parameterized. So at the top is the base FIST design, and its frequency is every year. And these were the inputs that we had in past MSC simulations. So the coastwide WPUE CV was 3%, and the assessment CV was 15%. And that assessment CV was determined. So if you remember how we do the MSC simulations right now, is we just simulate the error on the TCY and the error on the stock status. And that's a CV of 15% on both of those. So we'd say this is the TCY that would be calculated with perfect information. And then we just add error to it. And that's to avoid having to try to simulate all these ensemble approaches and things like that. And that was determined from a lot of work that we did many years ago. So then we all sat down and had a discussion. Okay, how do we parameterize the MSE? Well, with the base block design, the state space model results suggest it goes to a 4% CV. And the assessment CV, we suggested a 2 to 3% change. So we said, let's just bump that up to an 18% CV on the assessment. Noting that this base block design would occur every year. There's no bias on the coastwide WPUE, and there's no bias in the assessment. So this base block is really all the results that I showed you previously were based on the base block. And that's why I said some of the uncertainty had increased from previous simulations. When we go to the core design, when thinking about this, we thought we can't do a core design indefinitely. So MSC simulations are going out, 60 some years. We can't simulate a core design for 60 some years. That just would not happen. And so we've said its frequency is going to be every 2 to 4 years. It's only going to occur for 2 to 4 years. And then a base block design is going to occur. And I'll show you exactly how that affects the bias and stuff like that. So that's just the assumption that we make here. We increased the CVs for the core and the reduced, and we also have a bias now. And that bias is going to occur, not just put in a bias, it's going to increase annually. So more often you do this reduced core, the bias is going to keep creeping up in some way. And it's going to be dependent on what the spawning biomass trend is doing. So Ian had to make an assumption about the trend is. I can't make an assumption in the simulations what the trend is. The MSE is just naturally simulating the trend, right? It's through its dynamics. And so I'll explain on the next slide exactly how the bias creeps in with the trend that's being simulated in the MSE. And then the assessment CVs increase, and then there's also a bias on the assessment as well. So to get into more details of the core and the reduced, and I realized, no, it's not, it's small. text on there because this is reproduced from the document, but I just want to give you a general overview. There's three concepts: the frequency, how often, how many years the core design or the reduced core occurs, the bias that results in the FIS estimate, and then the bias that results in the assessment estimate. So with the frequency, we said if the spawning biomass is less than the spawning biomass was in 2020, then we would have a survey that's not very that would not be revenue neutral, and so we wouldn't be able to do the base block as often because the catch rates are low and profit is low and stuff like that. So if we're where we are now, then we're doing the base block every 5th year. And if we're at a higher biomass, it's likely we could do the base block more often because we have more fish out there and stuff. So then we said every 3rd year the base block would occur. And what happens when the base block design occurs is we just have the bias that's present in the system at that time. And so how does the bias occur? We have the bias increases. Well, if there's no current trend, so if the spawning biomass, is it the spawning? Yeah. 3-year coastwide trend, and this is in the spawning biomass. If there's been very little trend, less than 5%, then we just add a random amount of bias, 0.5%, and it's additive. So that as this core design occurs, every year we add a little more bias to it. So that's just a negative or positive 0.5%. As the trend in the recent biomass increases, so if it's 5 to 15%, the additive bias is 1%. If it's 15 to 30% increase recently, then it's a higher bias. And if it's greater than a 30% increase, then it's a 3% bias. So we're just having this additive bias occur. A base block design cuts it in half and it goes back. But remember, the bias is going to be positive bias, but if the trend is going all of a sudden changes, then it's a negative bias. So this additive bias is more like a random walk occurring through the simulations. And the assessment bias occurs in the same way. It's just a smaller amount of bias than would occur on the FIS. And that's what Ian showed. And there's fishery dependent data going into the stock assessment as well. So that was, after many discussions, just how we said we got to decide on some way to introduce these concepts on the FIS design, bias, and CV. And this is the way that we implemented it into the MSC simulations. So all this work, and as Ian said, it's a lot of work going into these simulations, and then we can present the results in one slide, right? And so with these different FIS designs, there's no conservation concern. So the control rule really seems to be kicking in and keeping it from really low biomass, 20%. The probability that the relative spawning biomass is less than 36% is slightly reduced with the smaller designs. And that's because the TCY is also reduced with the smaller design. So on average, the TCY is less going to the core and then even less going to the reduced core. I looked at the quantiles of the TCY to see if these designs had an effect on the range of TCYs that would be realized. And they didn't, and the reason is, some of these simulations say, oh, you would have a TCY in the 20 million pound range. And then other simulations say it could go up to 100 million pounds. It's just a huge range in TCYs. It affected the median by reducing it, but didn't affect those outer quantiles as much. So it didn't cut it off, by a large amount. And then the AAV increased with the smaller designs, as you would expect. So we have reducing the design, reduces the TCY, and increases the interannual variability. So bad and bad. These are plots showing across different fishing intensities from 43% to 52%. And you see that across the fishing intensities, it's the same pattern. There's no real difference across these fishing intensities. So what does this mean? In summary, as I said, lower TCY, higher interannual variability. These are all long-term results. So we're really now trying to bring in that concept of saving fish or taking too many fish out. So to summarize some things with an SPR 43%, our current interim reference point, the median TCY declined about 450,000 pounds, so 500,000 pounds going to reduced, and another 500,000 pounds going to the core, and then another 500,000 going to the reduced core. So going from base block to reduced core is almost 1 million pound reduction in median TCY. And at $6 a pound, that's $2.7 million. So this is trying to equate it to the cost of the fishery for each 450,000 pounds. And those declines are similar actually with an SPR 52%. It was still about 450,000 pound reductions. So, so that's a little bit less than the values that Ian was presenting from his assessment simulations. I think that's the difference between the short-term results, taking it all now versus the saving it in the long term. So it's just a little less effect in the long term. There's also this non-economic value to the fish, as Ian also explained. It's used sometimes when making decisions. It's important to stakeholders. It's compared to fishery trends. And it's just a better understanding of, it lends to a better understanding of the demographics. And I think there's a lot of inputs into the stock assessment that are not just the FIS WPOE. There's age compositions, there's the weighted age, and other things as well. So that's the summary of that. And sort of wraps up all of the MSE simulations that are not related to the depensation.
Can you just remind me, what's the deficit in, well, what's the cost of this design? That's the base block versus core.
Yeah. Yeah, that's a really good question, and I think I have to ask Dave or Ian on that one. I'm not that involved.
Something we're putting together for this paper, so we don't sort of deficit, but actually figure out what each of the designs cost, and when the revenue we get on a year-by-year basis is still pretty unknown. It's a large margin of error. But put a number on that. Ian, do you have the exact?
It's like $1 million between the low and high designs.
So that,
More than that. Yeah, this is more than that deficit.
right.
Exactly.
And that deficit wouldn't be there in all years. So you wouldn't just assume you'd lose that every year, because all years up to the last couple, the survey actually was long-term revenue neutral.
That's really helpful.
Yeah.
Putting it apples to apples comparison there, dollars lost without having a good survey design versus the cost of the survey.
Yeah, and so Ian and I both tried to do that with both of our simulation analyses. And as a reminder, coming into the 24th SRB of last June, I was saying these simulations would take a while. There still could be more work done on these simulations, and you asked for some preliminary results. So these are the results. So any advice on what you'd like to see for the next SRB meeting would be greatly appreciated, but we'll continue working on this. My suggestion is to not start the next session unless you want to go a little bit into the lunch hour. We could take lunch now, or we could start it. There's sort of subsections of the depensation stuff, but we could take it all together. Or take more questions right now, or have more discussion too.
I just have one quick question. Maybe this is something that we could look into for June. But so when you have a triennial assessment, you're running an empirical rule. So every third year, you get a new estimate of catchability.
So we're not
So
using catchability per se in the
you're
empirical
using the
rule.
change.
The change from the previous year. Yeah. So I imagine that factors out catchability if we did the algebra. I'd have done that at one point. We did it. That's how your empirical sort of rule work, your empirical fishing intensity or something that you develop from that is similar.
Yeah, because if you reset,
Yes.
so in the assessment year, what do you use, the empirical rule, or do you use the assessment to set the TCY in that
The
year?
assessment sets the TCY in that year. So if the change in catch or whatever, if a change in whatever scale occurs, it resets the TCY, and then the survey the next year is still proportional to its previous year.
So it does automatically.
Yeah, it rescales it. But it is assuming that catchability is constant, right? At least between the 2 years that the empirical rules operate.
Seems quite reasonable. Those 2 years. Okay, well, let's break for lunch.
Okay, thank you very much.
Back at now, 1:30.
1:30.
Thank you.